Welcome, everyone, to this Durga Analytics Explainer. Now, if you're a trader, a risk analyst, an operations specialist, or an engineer working in the energy markets, you know your entire world really revolves around one central platform. We are, of course, talking about the Energy Trading and Risk Management System, or ETRM. In this session, we're going to break down exactly what these systems are, the critical problems they solve, and why they are, without a doubt, the absolute backbone of any modern energy trading firm.
Just to give you a bit of context here, this is the very first foundational chapter in our big comprehensive program on OpenLink and DIR version 25. We're kicking things off right here in section 1, which is all about the market fundamentals. Trust me, mastering these core concepts is absolutely crucial before we even think about diving into the more advanced modules later on in the course.
So here's our game plan for today. We'll start with the why, the intense business challenges that even created the need for ETRM systems. Then we'll dissect the system itself, follow a single trade through its entire life, peek under the hood at the data and the code, and then tie it all back to governance and real-world impact before we nail down the key takeaways.
Okay, let's dive right in. Why do these multi-million-dollar systems even exist? Well, the short answer is one word: complexity. The days of trying to run a trading desk on a tangled web of spreadsheets are long, long gone, and for some very good reasons. I want you to just imagine for a second the sheer chaos of a modern energy trading floor. You're wrestling with just insane price volatility in oil, gas, and power. You've got these incredibly complex credit exposures to dozens of different counterparties. And on top of all that, you have real-world physical obligations, actually getting gas into a specific pipeline or power onto a grid, each with its own nasty physical constraints. Now, add in multi-currency settlements and a mountain of regulatory reporting like REMIT and Dodd-Frank, and you start to see why a simple spreadsheet doesn't just fail, it becomes a multi-million-dollar liability just waiting to happen. The risk of one wrong formula, one broken link, it's simply catastrophic. And that, right there, is the exact problem the ETRM system was built to solve. It is the enterprise-grade answer to all that chaos. Think of it as a single, centralized platform, engineered from the ground up to manage every single aspect of a trade's life. And most importantly, it establishes the one undisputed single source of truth, one version of reality that everyone, from the trader in the front office to the accountant in the back office, operates from. So what's actually inside one of these systems? Let's break down the anatomy of an ETRM, and we'll start with a really common point of confusion: the difference between an ETRM and a CTRM.
Now, I want you to look really closely at the physical focus and market integration rows here, because this is where the core difference lies. A CTRM, a commodity trading system, is a generalist. It can handle coffee, it can handle copper. But an ETRM is a specialist. It's purpose-built for the unique physical complexities of energy. We're talking about really intricate processes like pipeline nominations, power scheduling, and direct integration with grid operators, the TSOs and ISOs. This is the world where a specialized system like OpenLink and DIR really, really shines.
So inside a system like DIR, everything is organized into modules that perfectly mirror the structure of a real trading house. You have the front office module, which is the trader's cockpit for capturing deals. The middle office is the risk management hub, calculating all your key metrics like value at risk and credit exposure. The back office, well, that's the engine room that handles all the money, settlements, invoicing, you name it. And critically for energy, there's a dedicated logistics module that manages the complex physical movement of the commodity. All of this is then stitched together by powerful integration and reporting tools to create one seamless whole. So how do all these modules actually work together? Well, the best way to really understand the power of an ETRM is to follow a single trade on its journey through the system, from the moment it's executed all the way to its final archival for audit. Okay, so this journey unfolds across several key stages. It all starts with capture, where the trader punches in the deal. The system immediately runs validation checks against things like credit limits. Then it's priced using live market data, and its impact is calculated for risk reporting. For physical trades, we move to nomination, where the actual delivery is scheduled. Next, the trade is confirmed with the counterparty to make sure all the details match up perfectly. This leads to settlement, where invoices are generated. Finally, the profit or loss is posted to the general ledger for accounting, and the entire history is archived. The ultimate goal here, the holy grail, is straight-through processing, or STP, automating this flow to minimize errors and just maximize efficiency. And every single step in that life cycle is powered by specific data objects within the Endure database. The deal is like the master folder for the trade. It's made up of transactions that define the economics. Market data curves are used for the pricing. The counterparty is checked for credit. And events, well, those are system-generated triggers that kick off all the downstream processes like settlement. For anyone who is implementing, customizing, or supporting Endure, understanding this core data model is absolutely non-negotiable. Now, for all the implementers, engineers, and analysts in the audience, let's take a quick peek under the hood. How do you actually get your hands on all this data and automate processes within Endure? Well, the most direct way to query the system's data is with standard SQL. Here's a classic example an analyst might run every single day. It's a simple query against the AB-Tran table, which, by the way, is the massive central transaction table in Endure, where pretty much every economic event is stored. This pulls the key details for all the trades that were booked today. This kind of direct database access is a fundamental skill for anyone in a support, reporting, or data analytics role. But for true automation, for building real business logic, you use Endure's powerful proprietary scripting language, OpenJVS, which is basically Java. This simple script here automates the process of counting the day's trades. Now, why is that important? Well, you could schedule this to run automatically every evening as a critical completeness check, making sure no trades are missing before the big end-of-day risk calculations are run. This is how you embed robust, automated controls and custom logic right into the platform itself. So we've seen the business problem and the technical solution. Now let's connect it all back to the real world of compliance and governance. An ETRM isn't just a nice-to-have. In today's market, it's an absolute necessity. In both the US and Europe, the regulatory landscape since the financial crisis is just incredibly demanding. Regulations like Dodd-Frank and Europe's EMIR and REMIT, they mandate detailed, timely, and accurate reporting of every single trade to regulators. They require complete, unalterable audit trails of every single action. Trying to manually compile this data from spreadsheets isn't just difficult, it's basically impossible. An ETRM system is the engine that makes compliance at this scale actually achievable. And beyond just reporting, the ETRM is a critical governance platform. It enforces who can see or do what through role-based access. It creates an indelible audit trail of every single change ever made to a trade. It facilitates reconciliation with other systems and stores years and years of data for regulators. It's the system that ensures the business is operating within its own rules and, just as importantly, the law. We've covered a ton of ground, from the high-level business case all the way down to the low-level code. So let's distill this all down to the most important points to remember. If you remember only one thing from this entire explainer, let it be this analogy. An ETRM is the central nervous system of an energy trading organization. It receives sensory input, the trades, it processes them centrally, it manages risk, and it coordinates every single action across the entire business, from the traders making decisions to the schedulers moving the commodity and the accountants settling the books. So let's just quickly recap the core principles. An ETRM establishes the single source of truth. It manages the entire trade lifecycle through automation. Its success is absolutely built on a foundation of clean data and strong governance. It serves as a non-negotiable compliance engine, And a modern platform like Endure E25 is specifically architected with APIs and automation tools to thrive in today's high-speed algorithmic markets.
So we've now established a really solid understanding of the system itself. But a system is nothing without the people and organizations that actually use it. And this brings us to the next logical question. Who are the market participants? The utilities, the producers, the banks, the grid operators, whose actions actually drive the need for these powerful platforms in the first place? Well, we'll explore exactly that in our next chapter.
Welcome, everyone, and thank you for joining us here at Durga Analytics. Now, if you work in trading, risk, or operations, you know your entire business really hinges on one core system. I mean, get it right, and you've got a serious competitive edge. But get it wrong, and you're just constantly battling risk and inefficiency. So today, we're going to dissect the system that has become the enterprise backbone for so many of the world's top energy and commodity players, OpenLink Endure.
All right, before we really dive in, let's just quickly get our bearings. We're in Section 1 of our big program, which is all about the fundamentals of the energy and commodities market. This session right here is Chapter 2, where we're going to explore the strategic role that OpenLink Endure plays in this entire ecosystem. So, let's get right into it.
So here's our game plan for today. We're going to deconstruct Endure, starting with its strategic role as the enterprise backbone. Then we'll pop the hood and look inside its unified engine. After that, we'll see it in action with some real-world examples, and finally, we'll wrap up with a solid framework for mastering its implementation. Let's go.
Okay, first up, let's really establish why Endure isn't just another piece of software on a trader's desktop. No, it is the central nervous system of an entire trading operation.
When we say ETRM, or Energy Trading and Risk Management System, we're talking about the core platform. I mean, think of it as the one system that captures every single trade, calculates incredibly complex risk in real time, and automates the whole financial life cycle, right from the deal being captured to the final payment going out the door. It is the single source of truth, which, let's be honest, is the holy grail for any data-driven organization.
And see, Endure doesn't just live in one little corner of the business. It's the connective tissue that integrates every single function. It's grabbing deals from the front office, it's feeding data to the middle office risk engines, it's generating the financial entries for back office ERPs, and it's even talking to grid operators, like an independent system operator or ISO, to schedule the physical flows of a commodity. It truly sits at the very center of the entire operation.
Okay, so now that we get where it sits, strategically, let's look under the hood. Let's really get into the architecture that makes the Endure engine so powerful and, honestly, so resilient. The absolute secret sauce of Endure, its core power, is its unified data model. And look, this is not just some technical detail for the IT folks, it's a massive strategic advantage. Because it uses a single schema for trades, market data, and accounting, it completely eliminates those data silos that plague so many organizations. And what does that mean for you? Well, it means no more painful reconciliations and guaranteed consistency from a trader's real-time P&L all the way to that final regulatory report. Endure is built on this really elegant modular design where each part serves a very specific business function. Just imagine a seamless assembly line for a trade. It gets captured in the deal manager, then it's priced with data from the market manager, its risk is assessed in the simulation manager, it gets scheduled for physical delivery in the nomination manager, and then finally it's settled. Each module just hands off perfectly to the next one. It's beautiful.
Okay, theory is great, but let's connect that beautiful architecture to some real, tangible business outcomes. I want to give you some rapid-fire examples of Endure solving actual, real-world problems.
I love this slide because it just highlights Endure's versatility perfectly. On one hand, you have a U.S. utility that's struggling with complex valuation issues between their traditional power plants and their new renewable energy from solar power purchase agreements, or PPAs. At the same time, across the pond, you've got a European trading house trying to consolidate its hedging strategies across Brent crude oil and metals traded on the LME. Two totally different challenges, right? But one unified solution.
And hey, for all my friends in risk and operations, these numbers, this is what it's all about. An 80% reduction in manual reporting, a 90% drop in reconciliations. And my favorite, cutting the month-end close from 3 agonizing days down to 1. That's not just efficiency, people. That is a massive reduction in operational risk.
Okay, let's switch gears for the data analysts and support engineers in the audience. Remember that unified data model we talked about? Well, because of that, you can query its core tables directly. With a simple SQL statement, just like this one, you can immediately pull critical business information, like your top 10 deals by volume, right from the source of truth. No more waiting.
And for you developers and DevOps engineers, Endure is not a black box. You can use its native scripting language, OpenJVS, to automate incredibly complex business processes. Like, say, kicking off a valuation for every single active deal at the end of the day to generate the official P&L. You can build that automation yourself. So, we've seen what Endure is and why it's so powerful. Now let's talk about the really crucial part, implementation. Because, look, a powerful tool is only effective if it's deployed correctly. So let's walk through a blueprint for success. For all the implementers and consultants watching right now, listen up. This structured framework is non-negotiable. Jumping straight into configuration without designing first is an absolute recipe for disaster. And establishing strong data governance and automating your testing, those are absolutely critical for any kind of long-term success. Please, don't skip these steps.
All right, let's bring it all home. If you remember nothing else from this session, remember this. Endure's true value comes from its unique blend of deep, industry-specific business logic combined with a modern, extensible technical architecture. To really unlock its full potential, you have to master both the business side and the technology side. So as we close out, I want to leave you with a question to think about. Whether it's slow reporting, constant reconciliation errors, or maybe credit limit breaches. What is the one single bottleneck in your process right now that a truly unified system could just completely eliminate? Think about it.
We're going to build directly on this foundation in our next session. We'll explore the critical differences and interactions between physical and financial trading, and of course, how Endure handles both. Thank you so much for joining me today.
All right, welcome everyone from all of us here at Durga Analytics. You know, in the world of energy trading, you could have 2 deals on your screen. One is to sell, say, 1 million cubic feet of natural gas. The other is a financial swap based on that gas's price. On the surface, they might look pretty similar. But let me tell you, underneath, they are 2 completely different animals. They have different risks, different rules, different lifestyles. So today, we're going to break down that absolutely critical distinction and specifically how a powerhouse system like OpenLink Endure masters both. Okay, before we really get into it, let's just quickly get our bearings. For those of you following along with our full 500-chapter program, we are deep in Section 1, which is all about the fundamentals of the market. And today, we're hitting Chapter 3, Physical versus Financial Energy Trading. I've got to say, getting this concept right is absolutely foundational. It's the bedrock for everything else we're going to talk about, from risk all the way to regulation. So here's our game plan. First, we'll define these 2 very different worlds. Then, we'll trace their unique journeys right through the Endure system. After that, we'll dig into the data, how P&L and risk are handled so differently. And then, the really fun part, we'll see how it all comes together in the real world with a couple of case studies. Sound good? Let's jump in. All right, first up, the 2 worlds. To really understand why a system like Endure treats these trades so differently, you have to start with their purpose. Because even though they might sit next to each other on a trader screen, their fundamental goals, well, they couldn't be further apart. I think the best way to start is with a simple analogy. Think of your physical trading desk as a logistics company. Their whole world revolves around the actual stuff, the pipelines, the trucks, the ships. They are completely focused on making sure the commodity gets from point A to point B. Now, the financial trading desk, they're way more like an insurance company. They could care less about the trucks. What they care about is managing the financial risk tied to the value of what's inside those trucks. And that really brings us to the core difference, right? Their objectives. A physical trader's job is all about fulfillment. We're talking about literally moving molecules of natural gas or delivering megawatts of power. But a financial trader, their job is purely monetary. It's about hedging price risk, or maybe speculating on where the market's going to go. One is deeply rooted in physical reality, the other exists in the world of financial abstraction. And what's really fascinating here is how this one core difference just cascades down into everything else. I mean, just look at this table. The key modules in Endor are different. Nomination Manager for physical, Simulation Manager for financial. Even the regulations are totally separate. You've got REMIT for the physical flows and EMIR for the financial derivatives. The entire system has to be architected to handle these two completely distinct paths right from the very beginning.
Okay, so let's follow the journey, right? Let's trace both the molecules and the money. We're going to follow the life cycle of each trade type as it moves through the Endura system. You can think of them as these two parallel tracks that are, of course, deeply interconnected. So for a physical trade, the whole life cycle is a very logistics-heavy process. Once the deal's in this system, the next really critical step is nomination. That's where you're telling the pipeline or the grid operator what you plan to flow. And that's all handled by the nomination manager. The whole thing ends with settlement, but it's based on actual metered quantities. It's all about what was physically really delivered.
Now, this is where the contrast really becomes clear. The financial life cycle is, well, it's completely virtual. There's no nomination step at all. Instead, the trade gets linked up to market data, and the simulation manager becomes the star of the show, running valuations every single day. And settlement, it has nothing to do with delivered volume. It's just a pure cash exchange based on the difference between your contract price and the market price. Totally different world.
Okay, so we've seen the what. Now let's talk about the how. How does the Endura data model actually know the difference? Because this one single distinction, it drives literally everything downstream. P&L, risk calculations, credit exposure, you name it.
And this table right here shows a really critical difference in the world of accounting. For a physical trade, you don't really know your final profit or loss until that commodity is delivered and the invoice gets paid. But for a financial trade, the P&L is calculated every single day through what's called a mark-to-market valuation. This is stored in a key table AB ledger, and it reflects the trade's current value long before it ever actually settles.
So, how does the system know which path to go down? It all comes down to this. A single flag right in the core transaction table, AB-TREN. It's the delivery type field. A P for physical or an F for financial. That is the fundamental switch that tells Endor, okay, start the logistics workflow, or nope, start the valuation workflow. Everything flows from this one little data point.
And that simple little flag has a massive impact on risk management.
For physical trades, your credit exposure is backward-looking. It's basically, what am I owed for stuff I've already delivered? But for financial trades, credit exposure is forward-looking. It's based on the current unrealized mark-to-market value of that contract. See? Two completely different risk profiles, all driven by that one flag.
Okay, so you might be thinking, why go through all this trouble of managing these two incredibly complex worlds in one system? Well, this US case study is the perfect answer. This is where all the theory we've been talking about really becomes practice.
So this client, a huge integrated player, had a really classic problem. Their physical traders and their financial traders were living in different worlds, using totally different systems. And this created massive data silos and, frankly, reconciliation nightmares. The solution? Bring both trade types into one single, unified portfolio inside Jira.
And for the first time, they could finally get a true, holistic picture of their risk.
And the result? I mean, this wasn't just some minor improvement. It was a huge operational win. They saw a staggering 40% reduction in the manual effort they were spending just to reconcile their physical and financial books. Just stop and think about the hours, the headcount, the reduction in errors. That is a direct, tangible, bottom-line impact.
But honestly, beyond just the efficiency gains, the strategic benefit was immense. For the very first time, they had a single source of truth. They could see with perfect clarity just how effective their financial hedges were against their physical positions. The risk team and the treasury team were finally looking at the exact same reliable set of numbers. It was a game changer. Okay, let's look at another really powerful example. This time, we're jumping over to the European renewables market. And this case shows a much more sophisticated hedging strategy, linking a very long-term physical contract directly to financial instruments.
So here we have a renewable energy company. They've got a long-term 10-year power purchase agreement. That's a physical obligation to sell power. Now, to manage the incredible price risk over an entire decade, they use financial futures on the EEX exchange. And inside Endure, these two positions, which seem separate, are explicitly linked together using something called a hedge relationship ID.
And this just brilliantly shows the power of having a unified system. It gives them transparent hedge accounting, where the gains or losses on the financial hedge perfectly offset the revaluation of the physical PPA. And just look at the compliance win. Endure is generating both REMIT and EMIR reports for two totally different regulatory regimes from a single source of data. I mean, that is just incredibly powerful. All right, let's bring it all home and wrap up the key takeaways from this deep dive. So here's the bottom line. While physical and financial trading are completely distinct operationally, one is all about logistics, the other is all about valuation, their true strategic power is only unlocked when you manage them together. And that is the core advantage of a sophisticated ETRM system like Endura, giving you that single, holistic view of your risk, your P&L, and your compliance across both of those worlds.
So we've pretty much mastered the what, the fundamental difference between a physical and a financial trade. But of course, none of this happens in a vacuum. So in our next explainer, we're going to introduce the who, the traders, the utilities, the producers, the grid operators, all the key players who make up this massive, complex ecosystem. We'll see you then.
Welcome to this Durga Analytics Explainer. You know, in the world of energy trading, you've got this whole ecosystem of players. From a huge power generator to a lightning-fast trader, and every single one has a totally different goal. So the big question is, how can one system, like OpenLink Endure, possibly handle all of that complexity? Well, in this chapter, we're going to break down exactly who these key players are, and even better, we'll see the incredibly elegant way Endure models their entire world.
All right, just to quickly get our bearings, we're deep in Section 1, building up that foundational knowledge of the energy markets from the ground up. We've already covered what an ETRM system even is, and we've talked about that critical split between physical and financial trading. Today, we're hitting Chapter 4, and it's all about the who, the cast of characters that really make this market tick. So here's our game plan for today. We're going to start with the players who actually touch the physical stuff, the asset movers. Then we'll shift gears to the financial layer and talk about the market makers. After that, we'll look at the referees of the game, the system orchestrators. And then the part that ties it all together for us as Endure professionals, we'll pull back the curtain and see the brilliant data model that unifies this entire ecosystem. So let's get started with our first group.
First up, the asset movers. Now think of these as the participants with boots on the ground. They are fundamentally concerned with the physical commodity itself. You know, the actual electrons, the real molecules of gas, the barrels of oil. They represent the two essential bookends of the physical supply chain. You've got the people who create the energy and the people who consume it.
And right here, you can see the fundamental tension that really drives the physical market. On one side, you have the producer. Their primary goal is purely commercial: get the absolute best price and maximize the margin on the assets they own. But on the other side, you have the utility. Their main driver isn't profit, it's reliability, making sure they have a stable supply to keep the lights on for their customers. They are literally two sides of the same coin with perfectly opposite objectives.
So let's zoom in on the producer for a second. We're talking about power generators like Enel or oil and gas giants like Shell. Their entire business is about one thing: monetizing physical assets. And this is where Endor becomes their commercial command center. They're using it to manage long-term contracts, those power purchase agreements or PPAs, to schedule the physical flow of energy, and to run really complex simulations to forecast their revenue. And this slide, this is how Endor translates that abstract goal into a concrete digital reality. See, a producer isn't just some label in the system, it's a very precise configuration. A business unit might represent a specific operation, like a solar business in India. A portfolio groups together all their renewable contracts. The counterparty is simply who they're selling to. And here's the really cool part: integrating with plant-level SCADA systems to pull in real-time generation data. That creates a true digital twin of their physical operation, right inside the ETRM system. Now let's flip that coin over and look at the utility. Their goal isn't profit maximization in the same way a producer's is. It's all about stability and managing costs. For them, Endor is a procurement and risk management tool. They use it to execute their purchasing strategy, manage their PPA portfolio from the buyer side, forecast customer demand, and really get a handle on their cost exposure to make sure prices are stable for everyone.
Okay, so let's move from that physical layer up into the financial one. Our next group is the market makers. Now, if producers and utilities are the solid foundation of the market, you can think of traders and brokers as the financial lubricant. They operate in these abstract layers above the physical asset, and they provide the essential liquidity and price discovery that allows the whole market to function efficiently.
And it's so important to understand that trader isn't just one single role. You've got your pure speculators who are just betting on which way the price will move. You have hedgers who often come from the producer or utility side, using financial instruments to cancel out their physical risk. Prop desks trade the company's own capital for profit, while arbitrageurs are out there hunting for these tiny, fleeting price differences between related markets. Each one has a unique strategy, but they all rely on Endor as their high-performance engine. For a trader, Endor's not some back-office tool. It's a front-office weapon. The deal manager is built for one thing: speed, letting them capture complex trades in seconds. The simulation manager is their risk engine, calculating things like value at risk, the Greeks, which are key risk sensitivities, and their real-time mark-to-market P&L. The market manager is their strategic lens for curve analysis. And of course, the dashboards. That's their cockpit, giving them a live second-by-second view of their position. For traders, Endor is all about speed and analytical power. Of course, traders aren't operating in a vacuum. They're doing business through brokers and on exchanges like ICE or CME. In Endor, these venues are modeled very elegantly as just a special type of counterparty. But the real power comes from the integration. Trades that are executed on an exchange can flow automatically into Endor, using standard protocols like FIX. This creates a seamless, straight-through processing workflow from the front office all the way to the back.
All right, let's move on to the referees and the rule makers of this whole ecosystem. Now, these participants, they don't trade for profit. Their entire purpose is to make sure the market is stable, reliable, and fair for everybody else. These are the independent system operators and, of course, the regulators.
The ISO, or the TSO over in Europe, has one of the most complex and critical jobs in the entire ecosystem, literally keeping the lights on. They are in a constant real-time battle to balance electricity supply and demand on the grid.
To manage this chaos, they operate organized markets, they publish the official prices everyone uses for settlement, and they act as the central clearinghouse. In short, they are the air traffic controllers of the power grid, and their role is absolutely non-negotiable.
And this is what makes the digital link between a company's Endure system and the ISO so vital. It's a high-stakes, two-way street. Companies use Endure to push their schedules, or what we call nominations, out to the ISO. And in return, Endure is constantly pulling critical data back in, like real-time prices and the actual metered volumes. Any failure or delay in this loop results in immediate and very costly imbalance penalties. And finally, overseeing this entire game are the regulators. We're talking about entities like FERC in the US or ACER in the EU, who define the rules of engagement. You know, after the 2008 financial crisis, a whole wave of new regulations like Dodd-Frank and EMIR came along, and they created this massive compliance burden by forcing companies to report nearly every single trade to a central repository. This is exactly where modern ETRM systems became indispensable. Endure is architected to be a compliance engine. It takes the raw trade data that's already captured, enriches it with critical information like legal entity identifiers from tables like party_LEI, and then it automates the generation of these regulator-ready reports. It basically transforms what would be a massive manual headache into a streamlined, completely auditable process. So we've got producers, utilities, traders, regulators, all with completely different goals and data needs. How on earth can one system possibly serve all of them? Well, the answer lies in the elegant and incredibly powerful core of Endure's design, its unifying data model. It all begins with a single foundational concept that's captured in one master table, party. The simplest way to think of this is as the master address book for the entire market. Every single entity we've talked about today, Shell, PJM, a specific trading desk, a utility, is first defined with the unique master record in the party table. This establishes the who. But, just knowing who an entity is isn't enough. The system needs to know what it is. And that's the job of this simple yet incredibly powerful table. Party class. It links directly to the party table and it assigns a role. It's how the system knows that Shell is a producer, NG is utility, and PJM is an ISO. This classification is the absolute linchpin for all the reporting and analysis that comes later. And right here, this is where you see the powerful result. By joining just these two simple tables, you can immediately generate critical business insights. You can instantly see your trade volume with producers versus your trade volume with traders. You can group your credit risk by the type of counterparty, not just by their name. This elegant structure is precisely what allows Endure to deliver a single consolidated view of the entire ecosystem. It's what creates that single source of truth. Okay, let's bring it all home and really crystallize the key takeaways from our deep dive into market participants. So, if you remember just one thing from today, make it this. The energy market is a really diverse ecosystem, and Endure's true power comes from its ability to model every single one of these distinct actors within a simple, unified data structure, all starting with party and party class. Getting this configuration right is absolutely non-negotiable. It is the bedrock for all accurate reporting, from front office P&L all the way to back office regulatory filings. You just can't hope to master advanced modules like credit risk or market risk until this foundation is rock solid. So far, we focused entirely on the who, all the actors in this complex market play. But that naturally leads us to the next big question. We know the players, but what about the what and the how? How do the actual commodities they trade, the power, the gas, the oil, how do they actually move through their physical and financial life cycle?
And that question is the perfect lead-in to our very next chapter. In Chapter 5, we're going to trace the complete commodity value chains. We'll follow the journey of these commodities all the way from the wellhead to the burner tip, exploring exactly how Endure models that intricate path between the physical and financial worlds. Thank you so much for joining this Durga Analytics Explainer, and I look forward to seeing you in the next session.
All right, welcome back to our expert series on OpenLink Endure V25, brought to you by Durga Analytics. In our last session, we talked about who is in the market. Today, we're shifting focus to the how a commodity actually makes its journey from the ground to the consumer. And let me tell you, this is where the real complexity and, frankly, the real value is hiding.
Now, just to quickly remind you where we are in the grand scheme of things, we're still in Section 1, laying down that absolutely essential foundation of market fundamentals. We've covered what an ETRM system is and who the players are. Now, we're about to tackle one of the most vital concepts for any ETRM professional, the value chain.
We are diving right into Chapter 5, Commodity Value Chains. So, why is this so critical? Well, it's simple. Every single trade, every risk calculation, and every settlement processed in a system like Endura is fundamentally tied to a physical journey. If you don't understand that journey, the rest is just numbers on a screen.
So, here's our roadmap for today. We're going to start with the core problem that every multi-commodity trading desk faces. Then, we'll trace the very different paths of network-based commodities like power and gas, and then cargo-based ones like oil and LNG. We'll also explore the unique world of renewables. And finally, the best part, we'll see how Endure manages to bring all of these different worlds together into one single powerful view of risk. Okay, let's start with the big picture. What are we even talking about when we say value chain, and why is it really the central organizing principle for everything we do in the world of ETRM? The easiest way to think about a value chain is as the entire life story of a commodity. You know, it's not just a list of transactions. It's a physical story with a beginning, a middle, and an end. From the second a molecule is pulled from the ground to the final invoice being paid, every single step adds cost, complexity, and, most importantly for us, risk that has to be managed. And that brings us to the multi-trillion-dollar question, right? The very question a sophisticated system like Endure was designed to answer. How on earth do you create one coherent picture of reality when you're trying to manage the instantaneous flow of electricity, the daily nomination of natural gas, and the month-long voyage of an LNG tanker, all at the very same time? So, let's break this down. We'll start with our first category, network-based commodities. These are the assets that don't really live in a barrel or a silo. Their entire existence is defined by the physical networks they travel on, the power grids and the gas pipelines. The power value chain, it's a world of pure immediacy. I mean, a megawatt is generated, transmitted, and then consumed almost in the same breath. For an ETRM system, this means risk management isn't a daily thing, it's an hourly, sometimes even a 5-minute challenge. The key variable here is almost always the locational marginal price, or LMP. Think of LMP as the grid's way of telling you exactly where it's under stress and where the bottlenecks are. Now, this slide is great because it really highlights a critical difference. Yep, both power and gas are network commodities, but they operate at completely different speeds. Power is like a high-stakes balancing act against real-time volatility and grid congestion. Gas, on the other hand, moves at a much slower daily rhythm. The biggest risk there isn't a sudden price spike, but making sure your nominations get accepted by the pipeline operator and that you have enough gas in storage to meet your obligations tomorrow. Okay, let's completely shift gears. We're moving away from the abstract world of electrons and molecules on the network to the very real, very tangible world of global shipping. With cargo-based commodities, we're not just managing flows, we're managing massive vessels, complex logistics, and delivery cycles that can span weeks, even months. When it comes to oil and refined products, Endura has to capture that entire sprawling journey, from the wellhead all the way to the pump at the gas station. This is where the system's deep physical modeling capabilities are absolutely essential. We're not just booking a simple financial swap here, we're building detailed cargo deals, attaching complex freight components to model all the shipping costs, and managing things like potential delays and penalties, what we call demurrage.
And then you have LNG, which takes all that complexity and adds a really fascinating twist, a fundamental change of physical state. It's the only major commodity that starts as a gas, becomes a liquid for transport, and then has to be turned back into a gas at its destination. For Endar, this means tracking that same molecule as it's supercooled, shipped across an ocean, and then regasified. This process creates huge logistical puzzles, but also incredible trading opportunities, like playing the price spread between the JCAM index in Asia and the TTF hub in Europe.
And finally, we get to the newest player on the field, and in many ways the most complex, the renewables ecosystem. What makes this value chain so unique is that we are trading two different things at the same time: the physical energy and its environmental attribute. So, here's the key insight you have to grasp. When a wind turbine generates 1 megawatt-hour of green electricity, it also creates a second, entirely separate, tradable asset, a Renewable Energy Certificate, or REC. A modern ETRM system like Ender has to manage both. You have to settle the sale of the physical power, sure, but you also have to track the inventory, the sale, and the eventual retirement of that certificate. And this isn't just a nice-to-have. It's absolutely critical for compliance and for the world of ESG reporting. Okay, so we've just walked through 5 incredibly different commercial and physical realities, from hourly grid flows to global LNG voyages. How on earth does a single piece of software create a unified, coherent map of risk and value across all of them? This really gets to the very heart of Endur's architectural genius. You see, a lot of older systems just bolt on modules for different commodities, creating this messy patchwork of data silos. Endur's real power is its ability to synthesize all this incredibly diverse information into a single, unified data model. This means your power position can talk to your gas position, which can talk to your LNG cargo. It's all connected. And this table is the perfect illustration of what that unified model is built to handle. I mean, just look across the rows. The delivery cycles, completely different. The main price drivers, they live in different universes. The key risks you're worried about, totally distinct. Each column here represents a unique business, but Endure accommodates all of them with specialized modules that all feed into the same core risk and settlement engines. That's the definition of a true multi-commodity platform. And look, this isn't just some abstract architectural benefit. It has a massive impact on the bottom line. There was a real-world case study of a major trading house that moved to Ender's unified model, and they saw a 15% reduction in the capital they had to hold against their positions. Why? Because for the first time, they could accurately and confidently see their net risks across all commodities, giving their CFO and the regulators a true firm-wide view of their exposure. Now, for the more technical folks in the audience, this slide right here is the ultimate proof. The ability to write a simple SQL query against a single data view and instantly get a consolidated P&L report across your entire business, well, that's revolutionary. In a siloed world, getting this number would take a team of analysts weeks of painful reconciliation. In Endure, it's a real-time query. And this is what that query gives you. In one clean view, you have your entire portfolio's P&L and volume. This isn't just a report, it's a strategic tool. You can see right away that your profitable power desk is offsetting some losses in your physical oil portfolio. This is the kind of insight that leads to better trading decisions and smarter capital allocation. This quote really just nails the ultimate business benefit. A unified system isn't just about making life easier for your IT department. It's about creating coherence across the entire business. It means your regulatory reports, your financial statements, and your physical operations teams are all singing from the same song sheet because they're all drawing from the same single source of truth.
So, if you take away one thing from this whole explainer, let it be this. A world-class ETRM like Endure doesn't just treat all commodities the same. It deeply understands and adapts to the 5 unique physical and economic realities we just talked about. It isn't just a trading system. It's a sophisticated physical logistics and risk management engine that knows the fundamental difference between a megawatt, a barrel, and a renewable energy certificate.
Now, having this deep understanding of the physical journey, the what and the where, is the absolute foundation. But it naturally leads us to the next big question. Now that we know how these commodities move, how in the world do we price all the different types of deals that happen along these incredibly complex chains?
Well, we'll tackle exactly that in our next explainer, Chapter 6, where we will dive into the critical differences between spot and forward markets. We'll see you there.
Hey everyone, and welcome to the Durga Analytics Deep Dive on OpenLink Endure V25. Today, we're getting into a really foundational concept in energy trading, the huge difference between spot and forward markets.
Look, our goal here is to get you way beyond the textbook stuff. We want to give you that practical, hands-on knowledge you need to really master Endure and solve those tough, real-world problems in the energy and commodity space.
And just to get our bearings, remember we're still in Section 1 of the program, laying down those all-important market fundamentals. We've talked ETRM basics, the key players, value chains, and now we're ready for the next piece of the puzzle.
So today in Chapter 6, we're unlocking something that's right at the heart of trading: spot versus forward markets. And let me be clear, understanding this isn't just a nice to have. It's totally non-negotiable for any serious ETRM pro. Why? Because it drives everything inside Endure, from how a deal is captured all the way to how it's valued and risked.
So, here's our game plan. We'll kick things off with the basic market differences, then jump right into Endure to see how it handles the life cycle of each trade type. After that, we'll get into the numbers, valuation, P&L, then cover some crucial automation tips and best practices, and wrap it all up with the key takeaways you can start using right away.
All right, let's start with this core idea: markets for today versus markets for tomorrow. Think about it this way. Walking into the grocery store to buy milk for tonight, that's a spot transaction. It's immediate. But ordering your big holiday turkey 2 months ahead of time at a price you agree on today, that's a forward transaction. One is about now, the other is all about planning for the future.
So the spot market is the here and now. It's where you trade commodities for delivery, well, almost immediately. We're talking day-ahead power on the PJM grid or next-day gas at Europe's TTF hub. The price you see directly reflects what's happening on the ground with supply and demand right this minute.
Now you flip that on its head, and you've got the forward market. This is all about the future. It's where 2 parties lock in a price today for a commodity that won't be delivered until some later date. It's not an exchange of goods right now. It's a solid, binding commitment to do business down the road. It's perfect for hedging, planning, and of course, speculation. Okay, this table is where the rubber really meets the road for us as Endure professionals. It translates these ideas into the system's language. For spot, delivery is immediate. Credit risk is super low, and Endure is grabbing that price from a live feed in the market manager. But for forwards, delivery is way out in the future. The credit risk is much higher because the deal is open longer, and the most critical piece of data is your configured forward curve. This right here is the blueprint for how Endure is built.
So how does this actually play out inside the system? Let's trace the life cycle for both of these trade types from Endure's perspective. It's fascinating to see how it processes a spot deal compared to a forward contract.
For a spot trade,
The life cycle in Endor is incredibly fast. I mean, it's quick. In deal capture, you flag it as a physical deal for spot delivery. The market data is a live price. The pricing is super simple. Volume times that spot price, and boom, you've got realized P&L. Then settlement kicks in and generates an immediate cash flow. It's a clean, transactional, in-and-out process. But the forward life cycle, oh, that's a completely different story. This is a marathon, not a sprint. The deal is captured with a future delivery window. The market data isn't one price. It's a whole dynamic forward curve. And the pricing isn't simple at all. It's a mark-to-market valuation against that curve, which creates unrealized P&L that changes every day. Settlement? That doesn't happen until the very end. This is all about managing a position over time.
So what this all means is that your Endor configuration has to be fundamentally different for each of these markets. You can't just wing it. Spot needs those real-time feeds for immediate valuation and has a pretty low credit impact. The forward setup, though, is all about the curves. Forward curves for pricing, discount curves for present value, all driving that periodic mark-to-market valuation and carrying a much bigger credit exposure over the life of the deal.
And that brings us to what's probably the most critical part for any trader, risk manager, or consultant out there, the financial impact. How does Endor actually calculate the value and risk of these positions? This is where the money's made and, more importantly, where it's managed.
This little formula right here, this is the engine of all forward valuation inside Endor. It's simple, but so powerful. The mark-to-market value is just the difference between where the market is trading now versus your original deal price times your volume. This is what calculates your unrealized profit or loss every single day as the market moves around.
You know, having all this data is one thing, but getting real insight means you have to ask the system the right questions. And a super common one is, hey, how is our spot book performing versus our forward book? So let's look at the exact SQL you'd use to ask Endor precisely that.
Now don't get hung up on memorizing the exact syntax here. The key takeaway is understanding what this query does. It's joining your P&L data with your transaction data, and then using a simple case statement on the delivery type to group all your P&L by either spot or forward. This is a seriously powerful and must-have tool for your reporting toolkit.
And when you run a query like that, the results can be incredibly revealing. Look at this example. You can see right away that the spot trading activities have made a profit of 180,000 euros. Great. But the forward book is currently sitting on an unrealized loss of 240,000 euros. This immediately screams to a risk manager that the forward curve has probably moved up since those trades were put on, creating a negative exposure that needs to be watched like a hawk.
Okay, managing all of this, especially the crazy complexity of a big forward book, means you have to move beyond doing things by hand. To go from just being competent to true mastery, you need solid automation and a strict commitment to best practices. That's how you guarantee data integrity and get accurate risk numbers. Here's a pro tip. The best way to deal with problems is to prevent them from ever happening. A bad valuation run can be an absolute nightmare, and it's almost always caused by bad data. So the big question is, how can we check that our forward curves are healthy before that critical end-of-day valuation process even kicks off? We do it with tools like this little OpenJVS script. This isn't just a report, it's an active health check for your system. The code dives into the IDX_historical data table, that's where your curve data lives, and it counts how many recent data points each curve has. If a curve is looking a little sparse, it shoots out a warning. A simple check like this can save you hours of headaches later. The big takeaway here is that you need to make these best practices second nature. Use consistent names for everything. Automate that curve validation we just talked about. Keep your physical and financial books in separate portfolios. Turn on MTM snapshots so you have an audit trail. Make sure your curves feed into all your downstream risk and BI tools. And for goodness sake,
Set up alerts for data failures. This is the blueprint for a mature, reliable ETRM environment.
Wow, okay, we have covered a lot of ground, from high-level market theory all the way down to database queries. So let's just take a moment to boil it all down into the most important takeaways that you can apply to your work in Endure.
All right, if you remember nothing else, remember this. Spot is the now, today's price, today's delivery, and it gives you realized P&L. Forward is the future, tomorrow's delivery at a price you agree on today, and that generates unrealized P&L. You absolutely have to configure Endures differently for each. And never forget, your entire market risk framework is built on the quality of your forward curves. That means automation and validation aren't optional, they are absolutely critical.
So, we've got a really solid handle now on both spot and forward physical contracts. But there's a whole other layer to this world. What happens when we move away from these one-on-one bilateral contracts and start using standardized, exchange-cleared instruments? Well, that brings us right to our next chapter. Join us next time as we dive into the world of futures, forwards, and options in commodities.
Welcome, everyone, to this deep dive from Durga Analytics. Today, we're going to unlock the secrets of the financial instruments that really drive the energy markets. That's forwards, futures, and options. We're going to explore how these powerful tools are used to manage risk and, create opportunities, all within the context of OpenLink Endure v25. So before we jump right in, let's get our bearings. We are in Chapter 7, Futures, Forwards, and Options in Commodities. This is all part of Section 1 of our massive 500-chapter journey through the world of OpenLink Endure. Now, we've already laid some of the groundwork, exploring the fundamentals of energy trading, so now it's time to roll up our sleeves and get to know the essential tools of the trade.
Here's our roadmap for today. We're going to start by building a really solid foundation. Then we'll put these instruments under the microscope to see how they stack up. After that, we'll take a look under the hood of Endure to see how it handles these financial powerhouses. And of course, we're going to get our hands dirty with some real-world code and tackle the all-important topic of risk management. Ready? Let's do this.
Okay, first things first, let's get crystal clear on what we're dealing with. These three instruments, they're the building blocks of modern financial risk management in the energy sector. It doesn't matter if you're writing code, analyzing risk, or keeping the back office running smoothly. A solid understanding of forwards, futures, and options is absolutely essential for success. I want you to imagine a bespoke suit, one that's tailored to your exact measurements. Well, that's a forward contract. It's a private, over-the-counter, or OTC agreement directly between two parties. You can specify every last detail, the exact amount of the commodity, the precise delivery location, a specific date. But all that flexibility, it comes with a price. And that price is risk. With no middleman to guarantee the deal, you're exposed to counterparty credit risk. That's the risk that the other side might not hold up their end of the bargain. So if a forward is that bespoke suit, a future is like a high-quality, off-the-rack suit. It's standardized, it's traded on a public exchange like ICE or CME, so you know exactly what you're getting, and there's a ton of liquidity. But the real secret sauce here, the real magic, is the central counterparty, or the clearinghouse. Think of it as this trusted third party that stands in the middle of every single trade, requiring a daily cash settlement called margining. This makes sure everyone plays by the rules and that the risk of default is virtually eliminated. And an option? An option is like having a golden ticket. You pay a small fee up front, we call that a premium, and in return, you get the right to buy or sell a commodity at a certain price, but you're not obligated to do it. It's kind of like having a reservation at a fancy restaurant. You can choose to go and enjoy the meal at the price you locked in, or if you find a better deal somewhere else, you can just decide to stay home. The choice is yours. This gives you incredible flexibility, protecting you from downside risk, while still letting you profit from any upside potential.
So, we've met the three main players in the world of financial energy trading. Now, let's put them in the ring and see how they really match up.
By comparing them side by side, we can get a much better feel for their strengths, their weaknesses, and most importantly, when to use each one to our advantage. You know, this slide really gets to the heart of the matter. It shows us this fundamental trade-off between flexibility and risk. See, on one end of the spectrum, you've got forwards, complete flexibility, but a high degree of credit risk. On the other end, you've got futures, highly standardized but very low credit risk, thanks to that magic of central clearing. And then right in the middle, you have options, which can be either customized or standardized depending on what you need. And inside Endor, each of these instruments has its own unique identifier, FWD, FUT, or OPT, so you can easily track and manage everything. Okay, so we've talked about the theory. Now let's get practical. How does Endor actually handle these complex financial instruments? This is where the rubber really meets the road, and it's essential for anyone who wants to master the art of energy trading risk management. I want you to imagine a single, seamless workflow that takes you from the very moment a trade is born to the moment it's settled. That's exactly what Endor provides. It all starts with the trader capturing the deal. From there, Endor's powerful validation engine kicks in, checking against credit and trading limits. Then, the system just works its magic, pricing the deal to market and running sophisticated risk simulations. For futures, it calculates the dealing margin. And finally, it takes care of all the nitty-gritty details, from settlement to regulatory reporting. It really is a beautiful thing. All right, let's roll up our sleeves and get our hands dirty. In this section, we're going to bridge that gap between theory and practice by looking at how you actually manage and query these instruments in the real world. For all you tech-savvy folks out there, this is where things get really, really interesting. Okay, let's say you're a European utility, and you want to lock in your gas price for the first quarter of 2026. So you enter into a TTF forward contract. Once that deal is booked in Endor, the system values it against the forward curve and tracks it all the way to settlement. Now imagine your boss comes over and asks for a quick snapshot of your forward exposure. No problem. With this simple SQL query, you can instantly see a breakdown of your exposure by time period, so you can make informed decisions on the fly. When it comes to futures, automation is the name of the game. Trades are often executed electronically, and those daily margin calls are handled automatically by the clearinghouse. But how do you know if it's all working correctly? Well, that's where this handy SQL query comes in. It lets you quickly reconcile the variation margin in Endor with the statements from your clearing broker, so you can have complete confidence in your numbers. Now, when you're dealing with options, volatility is king. In Endor, you maintain what are called volatility surfaces, which the system then uses to price your options and calculate their risk sensitivities. We call those the Greeks. These are just metrics that tell you how your options value changes as the market moves. For example, delta measures sensitivity to the underlying price, while vega measures sensitivity to volatility. With this simple SQL query, you can get a real-time view of these critical risk metrics and stay one step ahead of the market. These two real-world examples show how to apply these instruments to achieve strategic goals. On the left, a power trader uses a combination of forwards and futures to create a perfect hedge, totally eliminating basis risk. That's the risk that your hedge doesn't perfectly track the price of the asset you're trying to protect. Then on the right, an oil refiner uses call options to protect its inventory value. And by automating the delta hedging process, they reduce their hedging costs by a massive 12%. This just shows how options can create more sophisticated and cost-effective strategies. So, you've mastered capturing and pricing deals. That's great. But honestly, it's only half the story. The real challenge is managing the risk that comes with these complex instruments. In this section, we're going to explore how Endor can help you stay on top of your risk so you can sleep soundly at night. Think of margin as a security deposit. When you enter a futures contract, you put up a small amount of money up front, which we call initial margin. This just ensures you have enough skin in the game. Then, every single day, your position is marked to market, and you either receive or pay out the difference in cash. This is the variation margin. Endorse Credit Manager module makes it super easy to track and manage all of this, so you always stay on the right side of your clearing broker. Okay, here's a little pro tip that will make you a hero to your trading desk. By using Endorse's scripting language, OpenJVS, you can create an automated morning check that gives your traders a real-time view of their risk exposure before the market even opens. This allows them to make way more informed trading decisions and just stay ahead of the curve. It's a small thing, but trust me, it can make a huge difference. This slide is all about best practices. But look, it's not enough to know what to do, you also need to know why you're doing it. For example, why reconcile your margin daily? Well, to identify and resolve discrepancies before they become a big problem. And why validate your volatility curves? Because it ensures you're using accurate, up-to-date information to price your options. Following these practices just creates a more robust and reliable risk management framework. Now, let's talk about the dark side of derivatives. These are the common pitfalls that can really trip you up. Imagine pricing a complex options portfolio, but you're using a stale volatility curve. The results could be disastrous. Or what if you forget to expire an option that's now worthless? It could throw off your risk reports and give you a completely false sense of security. The good news is, these are all avoidable. By being diligent and using smart automation, you can navigate these treacherous waters with confidence. We've covered a lot of ground today, right? From high-level concepts all the way down to the nitty-gritty details of SQL code. So, what are the key takeaways that you should be sharing with your team? Let's break it down. At the end of the day, it all comes down to this. Derivatives are the key to unlocking the full potential of your ETRM system. They elevate it from just a logistics tool to a sophisticated financial risk management platform. And with Indor, you have a powerful, integrated system to help you on that journey. But remember, the system is just a tool. It's up to you to feed it with high-quality data and build smart automation around it. If you can do that, you'll be well on your way to becoming a true master of the game. And that brings us to the end of our journey for today. But before we go, I want to leave you with one final thought. Mastering these individual instruments is a huge accomplishment, but it's really just the beginning. The real challenge and the real opportunity lies in understanding their combined impact on your credit exposure. And that's exactly what we'll be exploring in our upcoming chapter on credit limits, margining, and collateralization. So, until then, thanks for joining me. I'll see you next time.
Welcome back to another deep dive from Durga Analytics. Today, we're really getting into the operational heart of energy trading, physical delivery, and the nomination cycles that make it all happen.
All right, just to get our bearings, remember we're in Section 1 of our Ender Mastery Program, laying down the market fundamentals. And this is Chapter 8. Now this chapter, it's a big one. It's the critical link, the bridge that connects a trade on a screen to the actual physical movement of a commodity. Okay, so here's our game plan. We'll kick things off with the core concept, then walk through the delivery lifecycle as it works in Endor. We'll look at some real-world examples, and then we'll get into the nitty-gritty of handling imbalances, integrations, and best practices for automation before we wrap it all up. Let's get right into it.
Okay, first things first, let's set the stage. When you boil it all down, this whole process is about one thing and one thing only: turning a contractual agreement into actual physical commodity flow.
So what is a nomination really? Think of it this way. It's your official declaration. It's you telling a grid operator or a pipeline company, the TSO, hey, I have a contract to move this much gas or power and I'm planning to do it now, at this specific time. It's literally the trigger for all physical action. And this slide, this is the one to burn into your memory. It boils everything down so perfectly. Trading, that's about making the deal, right? It's the financial agreement, the contract. But nominating, that is about physically moving the electrons or the molecules. This simple idea is the anchor for our entire discussion today. Okay, so now that we have the concept down, let's see how this plays out inside OpenLink Endure. And I want to be clear, this isn't just a click of a button. It's a full-blown life cycle with very distinct stages.
So a physical trade in Endure goes on a journey. A 6-step journey, to be exact. It all starts with capturing the trade itself. Then comes scheduling. That's where you create the nomination. That nomination is then transmitted to the operator. After that, you monitor for updates, you get a final delivery confirmation back, and then finally, you settle the invoice based on what actually flowed.
Now, this whole journey is managed by a few key modules inside Endure, and while they're all critical, the nomination manager is truly the heart of the operation. It's the central nervous system for scheduling, for sending out the nomination, and for handling the confirmations that come back in.
All right, enough theory for a minute. Let's make this real. We're going to look at two very different case studies, one from European gas and another from U.S. power, to see how this process actually works out in the wild.
So, first up, a classic scenario. Picture this. You're a trader and you've just bought 10,000 megawatt hours of natural gas for tomorrow's delivery at the TTF, the massive Dutch hoe.
Okay, so the trade's booked in Endure. What happens next? Well, the system grabs a pre-configured template, generates the nomination, and fires it off to the transmission system operator, usually as a standard XML message. Then you wait. The TSO pings back with a confirmation. And here's the kicker. What they confirm might not be exactly what you asked for.
And for all of you who live in the database, a simple SQL query like this tells the entire story, doesn't it? You can see it right there. We nominated 10,000 megawatt hours, but the operator only confirmed 9,980. Boom! Just like that, you've got a 20 megawatt hour shortfall. That's an imbalance, and now you've got to deal with it. All right, now let's jump across the pond and switch commodities. Complete change of scenery. We're now a utility scheduling 50 megawatts an hour into the PJM power market in the US. This is a totally different ballgame. It's not one big chunk for the day. We're talking about 24 individual hourly blocks.
And the communication protocol is different too. Here, Endure might be sending a CSV file to PJM's API. And the response that comes back is super granular, an XML file that breaks down the accepted megawatts for every single hour. Endure's job is to automatically parse all of that and update its internal records with the actuals. And again, the SQL tells the tale. Look at that hourly detail. Hour 1, no problem. 50 scheduled, 50 delivered. But look at hour 2. Something happened on the grid. There was a constraint, and we only got 48 megawatt hours through. This just goes to show you how dynamic and real-time power markets really are.
So, this gets us to a really crucial point. These little differences, these imbalances between what you scheduled and what actually flowed, they aren't just numbers on a screen. They have real and often immediate financial consequences. And managing that requires rock-solid system integration. And what's cool is how Endure can be configured to handle these penalties, because every market does it differently. In PJM, that shortfall might trigger a specific imbalance penalty event. Over at TTF, for gas, it's more likely to be rolled into a balancing cost that hits you during settlement. The system has to be smart enough to model both worlds. So how does all this data fly back and forth? Well, to make this communication happen seamlessly, Endure uses all the modern tools in the toolbox. We're talking REST APIs, often through open components for real-time data exchange. We're talking messaging queues like JMS or Kafka for high-volume telemetry. And of course, good old secure FTP for file-based stuff as a reliable backup. It's all automated with scheduled jobs running in the background. Okay, so let's talk about the end game here. The ultimate goal isn't just to manage this process, it's to automate it completely. The whole point is to squeeze out risk, boost efficiency, and get rid of that soul-crushing manual work.
The holy grail in this space is something we call straight-through processing, or STP, I mean, that's the dream, right? A trade gets booked and flows all the way through nomination to final settlement without a single person having to intervene. And the way we get there is by using Endor's powerful automation tools, like OpenJVS, to build custom scripts that handle things like daily reconciliation reports.
So, to actually pull this off and maintain control, the best teams all follow a similar playbook. You've got to automate your reconciliation. You have to use modern APIs for real-time updates. You need to archive everything for the auditors. And critically, you have to make sure your system's asset codes match the operators, and you build dashboards that scream at you when discrepancies get too big, like over 1%.
All right, we have covered a ton of ground. So let's take a step back and boil it all down. What are the big things you need to walk away with? Why does all this technical detail matter so much to your business?
I want you to remember this. Physical scheduling isn't just a back-office function. It is the living, breathing heartbeat of your ETRM system. This is the exact point where paper trades become real energy movement. Getting this wrong or getting this right directly hits your P&L, your risk profile, and your ability to stay compliant. It's absolutely non-negotiable.
And that leads us to the perfect final question. We figured out how to move the energy and get the confirmed volumes back. But the next logical step is, how do those final, confirmed numbers get turned into cash? How do they drive the invoices and the payments? Well, that is exactly what we're going to break down in our next chapter as we connect these confirmed deliveries to the entire financial, settlement, and invoicing workflow.
Welcome. In any modern ETRM system, that connection to global energy exchanges, well, it's not just a feature, it's the absolute heart of the operation. So today, we're going to do a deep dive into how OpenLink Enter pulls this off, bridging that critical gap between the live market and your risk book.
All right, so just to get our bearings, this is Chapter 9 of our big Endor V25 program. We're talking about exchanges and marketplaces. Now, this is a super important connection to make. In the first few chapters, we kind of laid the groundwork for the system. Now we're plugging it directly into the source of all the action, the global exchanges. This is where all that theory really hits the road.
So here's our game plan for today. First, we'll get a lay of the land, the global exchanges. Then we'll nail down the difference between trading on an exchange versus over-the-counter. After that, we're going to follow a single trade on its journey right into Endor, unpack the really important mechanics of clearing and margin, and then we'll wrap up with some expert-level automation and best practices you can actually use.
Okay, let's start with the global arena. You know, exchanges are so much more than just a place to trade. They're really the epicenters for price discovery and for liquidity. They set the benchmarks for pretty much every commodity on the planet, which means having a direct connection to them is, well, it's non-negotiable. For an ETRM system like Endor, the exchange is the source of truth.
This table really just shows you how diverse this whole landscape is. I mean, you've got ICE, which is just a giant in oil and gas in both the US and Europe. You've got EAX, which is the key place for European power, and of course CME, home to massive benchmarks like WTI crude. Now, the big takeaway here isn't just the names. It's that Endor has to be multilingual. It has to speak the unique technical language of every single one of these venues and their clearinghouses, from ICE Clear to ECC. If you get that wrong, you're flying blind. You just aren't seeing the whole market.
All right, now that we've seen the venues, let's zoom in on the two totally distinct worlds of trading that happen there. Inside any ETRM system, you have to manage both. And trust me, understanding this difference is absolutely critical if you want to configure your system correctly.
So, on one side, you have your exchange-traded products. These are highly standardized, super transparent, and they have almost no counterparty risk. Why? Because a central clearinghouse guarantees every single trade. Then on the other side, you have the over-the-counter world, or OTC. This is all about flexible, custom-built contracts negotiated directly between two parties. The catch? Well, that flexibility comes with direct, bilateral counterparty risk and a lot less price transparency. The really crucial point here is that Endura is built from the ground up to handle both of these worlds at the same time, because honestly, a modern energy business just can't survive without both.
So, how does a trade that happens out there on the exchange actually make it into our system? Let's follow the data. Let's trace its journey from the exact moment of execution all the way to it becoming a permanent record inside the Endura database.
You have to think of this as a digital nervous system, and it all happens in milliseconds. So, step 1, a trade gets executed. The exchange immediately sends out a message using something called the FIX protocol. That's the Financial Information Exchange Protocol. It's basically the universal language of trading. Step 2, Ender's Open Components adapter acts like a translator, grabbing that message and making sense of it. And step 3 is where it becomes real. That data is written into the core transaction table, ABTRAN, creating a formal deal. And from that exact moment, it's ready for everything downstream: clearing, settlement, and risk analysis.
Let's make this tangible. Imagine a trader executes a December 2025 Henry Hub natural gas future on ICE. Instantly, a FIX message shoots out with all the details: price, quantity, contract code. The Open Components adapter catches it, understands it, and books a brand new trade in Endura, classifying it with the instrument type foot. And just like that, something that happened in the external market is now a structured, analyzable piece of data inside your risk system, all in near real time.
Okay, so once that trade is safely in the system, its financial life officially begins. The exchange clearinghouse guarantees the trade, right? But it doesn't do it for free. It needs a financial guarantee from both parties, and this whole process is called margining. Endura plays a huge role in managing this from start to finish. There are two types of margin you absolutely have to know. First up is initial margin, or IM. The easiest way to think about this is like a security deposit you pay just to open the position. It's a good faith deposit. Second, and this is the one that's way more active day to day, is variation margin, or VM. This is literally the daily profit or loss on your position. Every single day, the clearinghouse calculates it, and cash moves back and forth to settle up. This is the mechanism that prevents massive debts from ever building up between parties.
And here it is. This simple formula is the engine behind all that daily cash flow. The variation margin is just today's settlement price minus yesterday's settlement price, and you multiply that by the size of your position. This exact calculation is what Endura's Simulation Manager is built to do, every single day across thousands of trades, to tell you exactly how much cash your company is going to pay out or receive.
Okay, let's get into the really advanced stuff now. Managing these connections isn't just about getting the data in. It's about building bulletproof, automated processes to make sure your data is clean and your system is healthy. This is where senior consultants and support engineers really show their value.
Now this is a powerful insider best practice. What you're looking at is a simple script in OpenJVS, Endura's own scripting language. You can set this up to run automatically every morning before the market even opens. What does it do? It checks the database to make sure the latest settlement prices from ICE, from EEX, from CME have actually shown up. Think of it as your automated early warning system. If a price feed is down, you know about it before your traders start valuing their books on old, stale data, which, as you can imagine, is a recipe for disaster.
And that script? That's just one piece of the puzzle. These are the best practices that every single top-tier organization follows. You use separate portfolios for each exchange. It makes reconciliation so much easier. You automate bringing in those margin files to get rid of manual fat finger errors. And reconciling the exchange's mark-to-market against Endura's MTM every single day, that is absolutely non-negotiable. If those two numbers don't match, your firm's P&L is wrong. Period.
All right, let's bring it all home and lock in the most important points from what we've covered.
So, what's the big takeaway here? It's that exchange connectivity isn't just some IT task. It is a core business function. It's the absolute backbone of transparency and accuracy in your system. And a system like Endura doesn't just pull in data. It automates that entire life cycle,
from the moment of execution all the way to clearing and reconciliation. It creates this one, single, reliable ecosystem for managing all your market exposure. So, we've successfully followed a trade from the chaos of the marketplace right into our system. It's booked, it's being margined, it's valued correctly. But that just leads to the next big question, which we're going to tackle in our next chapter. Now that we have all this trade data in the system, how do we actually measure and manage the risk that it represents?
All right, welcome everyone, Durga Analytics here. Today we are getting right into the absolute core of market data. We're talking about the very foundation that every single energy trading and risk management, or ETRM, system is built on: indices and the sources that provide those prices. Now, just as a quick reminder for those of you following along with our full 500-chapter program, we are in Section 1. This is all about the non-negotiable fundamentals of the energy and commodities markets.
And right now, we are on Chapter 10, Indices and Pricing Sources. Last time, we talked about exchanges and marketplaces. Today, we're going a layer deeper to the very bedrock of how your system understands and assigns market value. Honestly, this is a make-or-break concept for anyone in this industry.
Okay, so here's our game plan. We're going to start with the basics, what an index really is. Then we'll peek under the hood at the architecture inside Endor. After that, we'll see how it all comes to life in real-world trades. And we'll wrap up with the absolutely critical topics of data validation and governance. Let's do it! First things first, let's get perfectly clear on what an index even is and why it's so vital. You know, we have to nail down the what and the who before we can even think about getting into the how. So, at its heart, an index is a benchmark price. It's published by what's called a price reporting agency, or a PRA. You can think of it as the official daily heartbeat of the market. It's the consensus price for a very specific thing, a specific commodity, at a specific location, for a specific time. And why does this matter so much? Well, look at this. Indices are basically the DNA of almost every critical function in an ETRM system. From pricing deals in the front office, to valuing your entire portfolio, all the way to settling invoices in the back office and reporting risk. Let me be clear, if your index data is wrong, everything that follows is wrong. So who are these trusted sources? Well, these are the titans of the industry, the price reporting agencies. You've got S&P Global Platts, Argus Media, and ICE Data Services. These are the organizations that pour immense resources into their methodologies to make sure these benchmark prices are credible, defensible, and trusted by the entire market. Okay, now let's pop the hood and see how a leading ETRM system like OpenLink Endor actually structures all this data. How does the software physically store and manage this incredibly vital information?
Now, for all the technical folks out there, the implementers, the support engineers, the developers, this slide is for you. This is gold. These are the main tables in the Endor database where index data lives. The IDX def table is like the master record. It defines the index. But IDX historical data, that's where the magic happens. That's where the actual daily time series of prices is stored. Knowing this structure is absolutely key to troubleshooting pretty much anything related to market data.
Okay, theory is great. Database tables are great. But let's connect this to the real world. It's one thing to know where the data is stored. It's another thing entirely to see how it prices the actual trades that cross a trader's desk every single day. Let's start with the rock star of all indices, Platts Dated Brent. This is, without a doubt, the benchmark for pricing a massive chunk of the world's physical crude oil. And this formula right here tells the whole story. The final price on the invoice isn't some fixed number. No way. It floats. It's directly tied to that published Brent dated index, plus or minus a little bit, a differential, that's negotiated based on things like quality or logistics. Your ETRM system has to pull in that Brent price every single day to value and settle this trade correctly.
Okay, let's switch commodities. We'll jump from global crude to European natural gas. Here, the Tidal Transfer Facility, or TTF, is the king. It's the dominant pricing point for the entire continent, and the day-ahead price from ICE is the cornerstone of this market.
And what do you know? It's the exact same logic. A physical gas deal is priced against the daily published TTF index plus some negotiated premium. You see the pattern here? This principle of a floating price tied to a trusted benchmark is universal across pretty much all commodities.
All right, let's level up a bit. Let's talk about a more advanced scenario. What if your contract is more complex? What if it references not just one, but two different pricing sources, like Platts and Argus? You'll see this sometimes when companies want to smooth out any potential volatility and not be reliant on just one source.
So how does Ender handle that? With something called composite indices. And for my technical audience, this is the actual SQL logic that could be running behind the scenes. You're basically telling the system, hey, go into the IDX historical data table, grab the Platts TTF price for today, grab the Argus TTF price for today, and then just give me the average. It's an incredibly powerful way to handle complex pricing formulas.
So, this brings us to an absolutely crucial point. If this index data is wrong, what happens? Your valuation is wrong. Your settlement is wrong. Your risk reports are wrong. Everything is wrong. This is why data validation isn't just a nice to have, it's mission critical. Let's talk about how you ensure you can actually trust your data.
Your market data team, or whoever is responsible, needs to have a disciplined, repeatable, daily checklist. Are we missing any data? Is there a price that looks totally insane, a fat finger error? Is the currency right? Do we have duplicates? These simple checks can literally prevent millions of dollars in errors down the line.
Here's a little gift for your support teams. This is a simple but incredibly powerful SQL query you can run right now. It just looks at that IDX historical data table and flags any index that hasn't loaded a full week's worth of prices. This is how you find out a data feed is broken before it blows up your end-of-day P&L report.
And if you want to build a truly robust, enterprise-grade solution, you automate it. You can take that same SQL logic and wrap it in an open JVS script that runs every morning. It gives your team a simple, clear green light or a red flag alert. This is how you move from being reactive to being proactive.
Okay, finally, let's talk about governance. Because managing all this data isn't just a technical challenge. It requires a solid framework, with clear roles, clear responsibilities, and a set of best practices that everyone follows.
And believe me, these are not optional suggestions. This is essential stuff for building a reliable and auditable ETRM environment. Having consistent naming conventions, for example, prevents so much confusion. Automating your validation stops errors before they happen. And defining what to do when a data feed fails, that can save your entire end-of-day process one day.
Look, if you walk away with just one thing from this session, let it be this. Your fancy, multi-million-dollar ETRM system is only as good as the data you put into it. Without accurate, timely indices from trusted sources like Platts, Argus, and ICE, the whole thing is basically just an expensive calculator that gets the wrong answer. It all starts with data quality. And that leads us perfectly to the next logical question, right? We've mastered today's price, the historical spot price, but trading happens in the future. So how do we take these anchor points, these indices, and use them to build forward-looking curves to price deals months or even years from now? Well, that is exactly what we are going to tackle in our next chapter, where we'll dive deep into volatility, curves, and seasonality. Thanks so much for joining me.
Hello, everyone, and welcome. I'm your trainer from Durga Analytics. You know, in the world of energy trading and risk management, almost every single critical decision, we're talking valuing a complex deal, calculating your firm's total exposure, it all starts from the very same place, the forward curve. So today, we're going to master curves in Open Link Endure.
And look, this isn't just about data points on a chart. It's about understanding the very DNA of valuation and risk. Let's dive in. Now, just as a quick reminder for those of you following our full 500-chapter program, we are deep inside Section 1, Energy and Commodities Market Fundamentals. And whether you're a consultant designing a new system, a trader looking to take a position, or a support engineer trying to figure out a P&L issue, trust me, the concepts we're covering today are absolutely foundational to your success. We are right here at Chapter 11, Volatility, Curves, and Seasonality. And I can't stress this enough. This is a critical chapter. Getting a deep understanding of this material is what separates a good analyst from a great one. Why? Because it's the absolute bedrock of how we quantify market value and risk.
So here's our roadmap for today. We're going to start with the why, the foundational role of curves, before we get into decoding the market's natural seasonality. Then we'll get our hands dirty building curves right inside Durga, and even look at some advanced tools like SQL. We'll tie it all together with some real-world case studies, and then finish up with the crucial topic of data integrity.
Okay, let's start with the big picture. Why are curves the absolute bedrock of every single energy trading operation? Well, to put it simply, they are the language the market uses to tell us what it expects to happen in the future.
Let's make this crystal clear. Every single mark-to-market calculation, every option premium, every value at risk report you run, it all flows from the data and the structure of your curves. I mean, if your curves are wrong, your valuation is wrong, your risk is wrong, and your decisions will be wrong. It is truly that simple.
The first and most important type is the forward curve. You can think of it as the market's consensus forecast. It answers the most fundamental question for any trader. If I want to lock in a price today for delivery next month or maybe next year, what is that price?
And its natural partner, of course, is the volatility curve. So if the forward curve tells us what the price is expected to be, the volatility curve tells us how uncertain that expectation is. It answers the question, how much could that future price swing around? This is the absolute core input for pricing any kind of optionality.
And this is where you really start to see the power of a system like Endure. You know, it's not just managing one or two simple curves. It's orchestrating this entire ecosystem. You've got forwards for price, volatility for options, basis curves for flotation spreads, FX and interest rate curves for all the financial calculations, and even seasonal profiles to capture those predictable patterns. Each one has a very specific job, and they all have to work together perfectly.
Okay, now let's talk about the market's natural rhythm. These are the predictable, cyclical patterns that shape energy prices year in and year out. We call it seasonality.
And this seasonality isn't just random noise, it's driven by real-world events. I mean, for power, it's that huge surge in summer air conditioning demand. For natural gas, it's the spike in winter heating. For oil, you have the summer driving season. Even emissions markets have these predictable spikes tied to compliance deadlines. If your models don't capture these rhythms, they are fundamentally incomplete.
All right, enough theory. Let's get practical. How do we actually build and configure these things inside the Endure system? Let's walk through the process inside Market Manager right now.
So, building a forward curve in Endure is this structured 7-step process. And you can see the logic here, right? You define what the curve is, you load your raw price data, and then you tell the system how to structure that data over time using what we call tenors. Then you apply the math, the interpolation rules for connecting the dots, and only after applying any seasonal adjustments and a final validation is the curve published and ready for everyone to use.
And here's a perfect concrete example. This is basically the control panel for a European TTF gas forward curve. You see, we've given it a unique name, linked it to natural gas, specified its official price source from the ICE exchange, and chosen a simple linear method to connect the price points. Every single one of these details matters.
Now, the process for a volatility curve is a little more direct. Notice the key difference here. After you input the raw vol data,
The most crucial step is number 4. You have to explicitly link this curve to the financial instruments, like a Brent call option, that are actually going to use it for pricing. That direct link is what activates it for valuation.
Okay, now for the technical experts in the audience. All you quants, support engineers, and developers out there, relying on the user interface isn't always going to cut it. To really validate our data and troubleshoot the tough problems, we need to go deeper. We need to go directly to the database.
This simple SQL query is a perfect example. With just one command, you can pull every single raw data point for our TTF forward curve right from the IDX historical data table. This is by far the fastest way to bypass the UI and see exactly what the system is using. It's absolutely essential for rapid-fire troubleshooting.
But we can get even smarter. This query here, this isn't for viewing data, it's a proactive health check. It automatically scans the database for any curve that has fewer than, say, 10 data points, a huge red flag for an incomplete or failed data load. Running this before your end-of-day process can literally prevent a catastrophic failure in your mark-to-market run. This is what we call fundamental automated risk control.
So let's connect all this technical detail back to real-world trading decisions. We're going to look at a couple of brief case studies that show these curves in action, starting with the U.S. power markets.
So picture this. Our scenario is a power trader in the PJM market, and they need to value options that only pay out during the peak summer months. Their analysis, which is driven entirely by curve data, reveals a critical insight. Both the expected future price, the forward, and the uncertainty, the volatility, are way higher in June, July, and August.
And there it is. The proof is in the data. The forward curve isn't flat. It correctly captures the summer peak, pricing August power significantly higher at $47.60 per megawatt hour. This is that summer cooling demand we were talking about, translated directly into a price. But here's the most crucial point. That higher summer volatility, it isn't just some abstract concept. It directly increases the price of the option. In this specific case, the shape of that volatility curve adds about 12% to the option's premium. I mean, that is a massive, quantifiable financial impact driven entirely by having the correct curve structure.
Okay, finally, let's talk about governance. Because look, building a perfect curve is only half the battle. Maintaining its accuracy, its reliability, and its integrity day after day, well, that requires robust processes and controls.
This table here should be a go-to resource for any support or operations team. Think of it as your first-level diagnostic guide. It links the most common symptoms, like a sudden MTM jump or a distorted curve, to their likely root cause and the standard procedure to fix it. This is how you move from just reacting to problems to having a structured, efficient process.
So, as we wrap up, I'll leave you with this question to think about. Your entire risk model, every single valuation you produce, it all hinges on the quality of these curves. So, how confident are you in yours? In our next chapter, we're going to build on this foundation by exploring the complex regulatory landscape. Think REMIT, Dodd-Frank, that governs all the trading activity based on this critical data. Thank you.
All right, let's just get right into it. If you're working in ETRM, you know that regulatory compliance isn't just some box you tick. It's a massive, high-stakes part of your day-to-day. So, in this deep dive from Durga Analytics, we're going to break down exactly how OpenLink and V25 handles this. Okay, just as a quick reminder of where we are, this session fits into our big 500-chapter program. Right now, we're laying the groundwork in Section 1, which is all about the fundamentals of the energy and commodities markets. And today, we're diving into Chapter 12, and this one is a biggie. It's an absolutely crucial deep dive into the regulatory landscape. We're going to be focusing on the 4 heavy hitters that you deal with constantly. That's REMIT, EMIR, Dodd-Frank, and MiFID II. You know getting this stuff right is non-negotiable, so let's get into it. All right, so here's our game plan for today. We'll start with from crisis to compliance, then hit the 4 regulatory pillars. After that, we'll look under the hood at Endur's compliance architecture, see how to automate the audit trail, and finally cover best practices and pitfalls. We're going to start with the why, what created all these rules, and then jump straight into the how, so you can really master this inside your Endur environment. Okay, first up, let's really set the stage. To get a handle on the rules you have to follow every day, you've got to understand why this incredibly complex, and let's be honest, sometimes frustrating, web of rules even exists. It wasn't just invented in a boardroom somewhere. It was forged in the fire of major market crises. And you can see that right here. What's so fascinating is you can draw a direct line from each of these major crises to a specific piece of legislation we live with today. You've got the Enron collapse in 2001. Bam! That kicks off huge transparency reforms. Then the 2008 global financial meltdown. That directly leads to Dodd-Frank and EMIR. And then, a few years later, market manipulation in the EU. Well, that sparks the creation of REMIT. These events literally force the industry out of the shadows of the old, opaque OTC markets and into the supervised, highly regulated world we're in now. All right, so with that history in our back pocket, let's now see how all those reactions came together to build the framework you have to navigate every single day. It's time to decode these acronyms and really put them into context.
Okay, think of this table as your high-level map. Your cheat sheet, really. It gives you that 30,000-foot view. You can see at a glance how each of these pillars, REMIT, EMIR, MiFID II, and Dodd-Frank, stakes out its territory. Each has a specific region, a very distinct scope of what it covers, and it tells you exactly who is on the hook for the reporting. Messing this up is pretty much the fastest way to a compliance headache. And what's really cool here is that this shows you the common DNA, the shared language across all these different regulations. It doesn't matter which one you're working with, you're going to run into these core data elements. The legal entity identifier, the LEI, that's universal. Everyone needs it. The unique trade identifier, the UTI, that's the absolute backbone for EMIR and Dodd-Frank. And you've got to remember, these aren't just random fields in a database. They are the fundamental building blocks of global compliance. Okay, so that leads to the million-dollar question for everyone here, right? How does a beast of a system like Endur v25 actually handle this mountain of data and all these complex rules? Well, that brings us right into its core compliance architecture, what I like to call the engine room. And I absolutely love this analogy because it's just so spot on. Think of Endur as this purpose-built regulatory compliance engine. A trade gets booked. That's your raw fuel. The key data points like LEIs and UTIs, those are the essential high-octane additives. And the Endur framework itself, that's the high-performance engine that takes it all, processes it, and what comes out the other side is a clean, compliant, and totally auditable report. So how does that engine actually run? Well, it's the super logical 5-step automated workflow. A deal gets captured. Right away, Endur gets to work enriching it, automatically assigning things like the LEI and UTI. Then it validates everything, checking for completeness and correct formatting. Next, it creates the reporting extract, the XML or CSV files. And finally, it transmits that data securely to the regulator. The whole point is to take a raw trade and get it to a fully compliant submission with as few manual touch points as possible, because that's where errors creep in. But here's the really crucial part. This engine doesn't just process data and then forget about it. No way. It meticulously records everything. It creates a complete, transparent, and totally regulator-ready audit trail of everything it's done. So if you're a compliance officer, or really anyone in an oversight role, this is your mission control. It's a centralized dashboard, often built using Endura's Data Mart, that's its dedicated reporting database, and it gives you this near real-time view of your entire reporting world.
You can see in a second what's gone through, what's failed, and what needs your attention, like right now. And this is the number that Dashboard is helping you chase, 99.5%. That's the goal. A near-perfect successful reporting rate, all done within that super tight T+1 deadline. And let me tell you, this isn't just a nice-to-have metric anymore. In today's world, it's the key indicator that separates a healthy, well-oiled compliance machine from a team that is just constantly putting out fires. So, what does all this really mean? It means traceability isn't some add-on. It's woven right into the fabric of Endor's regulatory module. You've got copies of all the files, timestamps for everything, creation, sending, acknowledgements. You have a full version history of any changes. You've got detailed logs for any failures, and it all integrates directly with the big repositories like Acer, DTCC, and Register. This gives you that rock-solid proof you need to walk into any audit, internal or external, with total confidence. Okay, so we've seen what the system can do. Now let's talk about implementation reality. How do you actually get the most out of this powerful engine? And maybe more importantly, what are the common traps that can completely derail your compliance efforts? All right, these right here are the non-negotiables. Seriously, think of this as your pre-flight checklist for a top-tier compliance setup. Automate your LEI and UTI population the second a trade is captured. Use pre-reporting checks to validate your data before it goes out the door. Set up automated retry logic for when transmissions fail, because they will. Maintain that audit trail for at least 7 years. And please periodically reconcile your data with the feedback you get from the trade repository. These are the proactive steps that make the difference between a low-risk, efficient operation and a high-risk, reactive one. And here is a classic, real-world pitfall we see all the time. A trade gets flagged for both MIR and MiFID II. You end up with an overlap, potential duplicate reporting. It's a mess. Now, the fix isn't to have someone manually go in and fix it every time. No, the fix is systemic. You go into Endor, you refine your classification rules, you make sure your product mapping is correct, and you solve the problem at the root so it never happens again. So, after all this, it really boils down to one question, and it's a question we want you to take back to your own team. Is your compliance process an automated, resilient engine, or is it a collection of manual processes that represent a huge, ticking risk? Really think about it. Are you running smoothly, or are you just one bad trade away from a major compliance headache? Look, mastering these regulatory modules isn't just a good skill to have. It is absolutely fundamental to succeeding in any ETRM role today. Now that we've got this down, in our next session, we're going to build directly on this. We'll see exactly how this critical compliance layer fits into every single step of the complete life cycle of an energy trade, from the moment it's captured all the way through to final settlement. Thanks so much for your attention.
All right, welcome. I'm with Durga Analytics, and today we're jumping into one of the most critical topics in our entire industry, risk. Specifically, we're going to break down the core risk categories in energy trading and, more importantly, how a powerhouse system like OpenLink Endor helps you get a handle on them.
Now, as you know, this is Chapter 13 of our massive 500-chapter deep dive into Endor v25. We've already built a really solid foundation in our first section on market fundamentals. We've talked physical versus financial, we've covered regulations. Now we're getting to the heart of it all, how we actually manage and strategize around risk using the platform.
So here's our game plan. We'll start with the big picture, the overall ETRM risk framework. Then we'll zoom in on what I like to call the 4 pillars of risk. That's market, credit, operational, and liquidity. And finally, we'll see how Endor's integrated engine brings it all together for that single, unified view.
Okay, let's get into it. You know, in energy trading, risk isn't some academic idea. It is baked into every single deal, every curve, every single day. So the job of a great risk team and a great ETRM system is to quantify it, keep an eye on it, and control it.
Think of Endure less like a simple database and more like the air traffic control tower for your entire trading floor. This table? This is basically our cheat sheet for today. It lays out our 4 pillars perfectly. You can see each one has its own definition, its own special way of being measured, things like VAR or PFE, and critically, its own home inside Endure's different modules. This structure is the absolute blueprint for getting risk under control.
So let's kick things off with pillar number 1, market risk. This is the one that gets all the headlines, the one traders live and breathe every single day. It's all about your exposure to the wild, constant swings of the market.
So when you boil it all down, market risk is just about answering a bunch of what-if questions. What if the price of gas collapses tomorrow? What if volatility in the power market suddenly goes through the roof? How much money do we stand to lose? That's the core question we're trying to answer here.
And to answer that, Endure gives us a whole shed of powerful tools. Of course, you've got your daily mark-to-market P&L, you've got your Greeks to measure sensitivities, and you have stress tests. But for most risk teams, the number they look at every single morning is VAR, or value at risk. It's an incredibly powerful metric. But, and this is important, you have to remember what it is and what it isn't. It's a measure of expected loss under normal conditions, not a magic crystal ball for predicting those crazy black swan events.
Okay, let's make this real. Here we have a European gas portfolio currently worth about 80 million euros. Endure runs its simulations and spits out a daily VAR of 2.1 million. So what on earth does that mean? Well, it means that on any given trading day, we are 95% sure that this portfolio will not lose more than 2.1 million euros. That single number is a massively important piece of information for management.
And this is where you really see the beauty of Endure's integrated design. All of that complex number crunching for VAR gets neatly packaged and stored in the data mart. That means with a simple SQL query just like this one, you can pull that critical number right into your daily reports, your dashboards, your alert systems. It's all about that seamless flow of data to make smarter, faster decisions.
Okay, so we've covered the what's, the market prices. Let's move on to our second pillar and talk about the who. Credit risk isn't about the market. It's about the financial strength of the people and companies you're actually trading with.
Let's put this plainly. This is the risk that the company on the other side of your deal goes bankrupt and can't pay you the money that they owe you. It's as simple as that. And it's a risk that can creep up on you, or during a crisis, it can happen all at once.
Now, what's really cool about how Endure handles this is that it's not just looking at what someone owes you today. That's rearview mirror stuff. Endure uses sophisticated simulations to calculate things like potential future exposure, or PFE. It's basically modeling how your risk to that counterparty could change and grow over the entire life of your trades. This is what true forward-looking risk management is all about. And here's that exact theory in practice. So our trades with this LNG counterparty mean they owe us, on paper, about $2.1 million. But we're holding $1.5 million of their money as collateral. So a quick subtraction tells us our net exposure, our actual money on the line risk, is only $600,000, which you can see is well within our $3 million credit limit. And Endure's credit manager tracks all of this automatically. And hey, just like with market risk, we can put the monitoring on autopilot. You can have a simple SQL query like this running in the background. The second any counterparty's exposure creeps up past a certain threshold, say 80% of their limit, bang, an alert goes out. It gives the credit team a heads up so they can act before it becomes a real problem.
So we've looked at the external world, the markets, and our counterparties. Now it's time to turn inward and look at the 2 pillars that are all about your own house: operational and liquidity risk. These are the ones that are often forgotten, but let me tell you, they are almost always at the scene of the crime when things go catastrophically wrong.
It's really important to see the distinction here. Operational risk is basically asking, did we mess something up internally? Did our process break? Liquidity risk, on the other hand, asks a much more brutal question. Do we have enough cash to pay our bills today? One is about process, the other is about survival. And you can have the best processes in the world, but if you run out of cash, it's game over. Operational risk is a huge bucket that covers all sorts of internal screw-ups. It could be the classic fat finger error, where a trader accidentally types 1,000,000 barrels instead of 1,000, or it could be a system job that fails overnight. Ender helps you build safety nets. For example, using OpenJVS and Doors scripting language, you can write little automated health checks that constantly watch your critical data feeds. If a price feed from ICE is even a few minutes late, it can trigger an immediate alert to your support team, preventing bad data from poisoning all of your risk numbers. Liquidity risk, this is the one that can take a company down in hours, not weeks. Imagine the market goes absolutely haywire. All of a sudden, you're getting slammed with massive margin calls from everyone, demanding huge amounts of cash right now. This is where firms fail, and this is where Endure can be a lifesaver. Its credit manager doesn't just track current margin, it actually forecasts future margin calls based on market movements. This gives your treasury team precious time, a crucial heads up to get the funding in place before it's a full-blown crisis.
Okay, so we've broken down all 4 pillars one by one. Now, let's put it all back together. Let's see how Endure's fundamental architecture lets you see the whole forest, not just the individual trees.
This is the real power of an integrated system. Endura is built on a logical hierarchy. This means you can start at the most granular level, a single trader's portfolio, and then roll that risk up. You can slice and dice it by book, by counterparty, by commodity, by your legal entity, all the way to the very top to get a single consolidated risk number for the entire enterprise.
And the result of all that aggregation is you can create incredibly powerful yet simple views like this one. With just one query, you can see your firm's total exposure neatly broken down by our risk pillars. In this case, you can tell in about 2 seconds that market risk is by far our biggest concern, followed by credit risk. For a chief risk officer, this kind of clarity is absolutely priceless.
We have covered a ton of ground, so let's bring it all home. Let's summarize the absolute must-know takeaways and talk about some best practices for doing risk management the right way in Endure.
Look, if there's one thing you remember from this session, let it be this. Good risk management is not a one-time project. It's a continuous, daily discipline. It's about automating everything you can, constantly monitoring your data, and regularly, at least quarterly, revisiting your models and your stress tests to make sure they still make sense in the current market. It's a process, not a destination.
So, as we wrap up, I want to leave you with this final question. Your systems, your Ender's setup, they are fantastic for monitoring the risks you know about today. But is your strategy robust enough to handle the risk that nobody sees coming? Mastering the tools is one thing. Being prepared for the unexpected is the real challenge. And that's the perfect setup for our next chapter, where we'll follow the entire life cycle of an energy trade and see exactly how these risks pop up from the moment a deal is done until the final invoice is paid. Thanks for joining me.
Welcome. This explainer comes to you from Durga Analytics, and today we are diving deep into our comprehensive OpenLink Endure V25 program. We're about to unpack one of the most critical processes in the entire energy trading world, the life cycle of a trade. Honestly, if you can master this journey, you're well on your way to unlocking the true power of any ETRM system. Okay, before we jump right in, let's just quickly get our bearings. We're currently in Section 1 of the program, where we're nailing down all the fundamentals of the energy and commodities market. So far, we've covered the basics of ETRM systems, different trading types, and risk categories. And now, today, we're hitting Chapter 14, the life cycle of an energy trade. This is the absolute heart of the entire process. So here's our game plan for today. We're going to start with a high-level blueprint of a trade's entire journey. Then we'll walk through its inception, how it gets valued and stress-tested, how its value is actually realized, and then cover the crucial oversight and control phases. And to wrap it all up, we'll talk about how you can truly master this entire flow. First things first, let's establish our map.
before we get lost in the weeds of Endor modules and database tables, we really need a clear, big picture view of what this journey actually looks like. So, what exactly is a trade life cycle? You can think of it like a factory assembly line, but for financial and physical commitments. Each station or phase adds another layer of validation or valuation or execution. I also like to think of it like a passport getting stamped at every border crossing. Each stamp validates the trade's legitimacy and allows it to move on to the next critical stage. It's this very structure that brings a sense of order to the absolute chaos of the markets. In this table, this right here is the Rosetta Stone for the trade life cycle in Endor. It's brilliant. It perfectly connects the business objective of each stage, like capture, to the specific Endor module that handles it, in this case the trading manager, and, most importantly, to the primary data table where this all lives, the famous AB-TRAN table. This is the blueprint we're going to be following. Okay, so let's move into our first phase and see how this all works in practice. How does a deal, which might just start as a phone call or a click on a screen, become this solid, validated, and agreed-upon record inside our ETRM system? Well, that's what trade inception is all about. Think of these first 3 steps as the gatekeepers of your system. First, you've got capture, where the deal gets booked. Simple enough, but then validation kicks in immediately. The workflow engine acts like a bouncer at a club, checking everything from credit limits to mandatory data fields. And finally, confirmation. Make sure that both you and your counterparty are looking at the exact same deal. It is all about getting it right from the very start. Now, for all of our more technical folks out there, the support engineers, developers, and analysts, this is how you can see this stage in its rawest form. This simple SQL query lets you talk directly to the Endor database and pull all those freshly captured gas forward deals. This is ground zero. This is the digital birth certificate of the trade, stored right there in the AB-TRAN table. So once the trade is captured and validated, it enters what I like to call the crucible of risk. This is where the deal stops being just a simple record of an agreement and becomes this dynamic object with a constantly fluctuating value and a very real, measurable impact on the company's bottom line. Now, you might ask, why is this so crucial? Let me paint a picture for you with a real-world example. Imagine a portfolio of Brent crude oil swaps. The market moves, just a seemingly minor 3% drop in the price of Brent, and suddenly the mark-to-market value of that portfolio plummets by $2.5 million. This is the reality risk managers live with every single day, and it's exactly what this stage is designed to calculate and control. So, to manage all this risk, Endor's Simulation Manager takes center stage. It just crunches the numbers, using all the latest market data to calculate key metrics like your mark-to-market and your P&L. It also calculates the Greeks, things like delta and vega, which, to put it simply, just measure how sensitive your trade's value is to different market moves. All of this vital intelligence gets stored in the SIM results table for some really deep analysis. All right, with the risk quantified and hopefully under control, the trade now makes its way from the middle office to the back office. And the main objective here is to actually realize its value. This can happen in one of 2 ways, either through the physical delivery of a commodity or the financial settlement of cash. This is where the rubber really meets the road. For physical trade, say, delivering power into the PJM grid, it's this incredibly complex dance of nominations and scheduling. For a financial swap, it's much simpler. It's just based on an agreed-upon index price. But look, in both cases, the goal is exactly the same. Turn that trade's theoretical value into a tangible asset, whether that's megawatts flowing on the grid or cold hard cash in the bank. And of course, every single dollar or megawatt that moves has got to be accounted for. So, when a settlement event happens, it triggers Endor's accounting engine. Now, the crucial point here is that this engine relies on a set of pre-configured mapping rules to know exactly which accounts to debit and which to credit. These entries get posted to Endur's internal ledger, the AB ledger table, before being shipped off to the company's main ERP system.
You might be thinking that once a trade is settled and the books are balanced, the journey's over, right? Well, in today's highly regulated world, not even close. The trade now enters this long-tail period of oversight, monitoring, and compliance that can honestly last for years. This timeline really illustrates the ongoing responsibilities tied to just a single trade. I mean, the day after the trade, regulatory reports are already due. Every single day, credit exposure is reevaluated. Data is constantly flowing to reporting dashboards. And even after the trade matures, it has to be archived and kept accessible for audits for as long as a decade. It's a continuous cycle, for sure. Now, what's really cool about this slide is how it takes that entire complex journey and boils it down into a clear data lineage. You can literally see the data flowing from one primary table to the next, starting with ABTRAN, getting valued in SIM results, settled through cash transfer, booked in AB ledger, and so on. Each step enriches the data and creates this unbreakable, fully auditable trail from day one all the way to archival.
Okay, so understanding this path is the first big step. But to truly master it, to run an efficient and low-risk operation, you need a deep focus on automation and a strict adherence to industry best practices. This is really what separates the novices from the experts. For all you advanced users and developers, Endure offers some incredibly powerful automation tools, like OpenJVS. This little code snippet here is a perfect example. It's a simple script that basically acts as a daily health check. It queries the ABTRAN table to find any trades that might be stuck in a particular status, say pending confirmation, and it flags them for attention. This kind of proactive monitoring is absolutely key to a smooth operation. And these 7 principles, these are the gold standard for lifecycle management. Things like validating at the point of entry to prevent that garbage in, garbage out problem, automating wherever you can to reduce manual error, and running nightly reconciliations to catch any breaks in the chain. Sticking to these is what creates a truly resilient and efficient ETRM operation. Ultimately, it all comes down to this. A deep, end-to-end understanding of this entire flow is what separates a good analyst or consultant from a great one. It's about being fluent in the language of both the front office, the deal makers, and the back office, the operators and accountants. That fluency, that's the true hallmark of an expert in this field. And that thought leads us perfectly into our next chapters. We've mapped the entire journey, but what about all the hazards along the way? This question, how do we manage the complex risks a trade encounters, sets the stage perfectly for our upcoming deep dives into the specific categories of risk: market risk, credit risk, and operational risk. We'll explore the specific tools Endure provides to manage each and every one. Thanks for joining this explainer, and I'll see you in the next one. Welcome back. You know, in any high-stakes trading operation, there's this constant battle between generating value and controlling risk. If you get it wrong, well, the losses can be catastrophic. But if you get it right, you build a resilient, incredibly profitable business. Today, we're going to dissect the very heart of that control structure, the distinct, absolutely critical roles of the risk and operations teams, and how they function inside Endure V25. This is a 400-level deep dive, so let's get right into it. All right, so just to orient ourselves, we're in Chapter 15 of our Market Fundamentals section. We've already walked through the life cycle of a single trade, but a successful business isn't about just one trade. It's about managing thousands of them. And that requires a rock-solid governance framework. So today, we're zooming out from that individual deal to look at the organizational blueprint that makes the whole operation actually work. So here's our game plan. We'll start with a foundational concept, this 3 lines model. Then we'll dive into each line one by one,
front, middle, and back office, really understanding what makes them tick. And this is the crucial part. We'll see how Endur's technology isn't just some tool they use, but it's the very backbone that enforces this separation. Then we'll wrap it all up by connecting it back to what it really takes to master this whole ecosystem. First up, the 3 lines blueprint. Now, I want you to think of this not just as some org chart, but as the fundamental operating system for governance, risk, and compliance in the energy trading world. I mean, there's a reason it's the industry standard. So, what is this model, really? At its core, it's a simple but incredibly powerful idea. You absolutely cannot have the same people taking the risks, overseeing those same risks, and then validating the final results. It just doesn't work. By creating this kind of firewall between roles, you build a foundation of transparency and you kill conflicts of interest before they even have a chance to start. This table right here, this is basically the Rosetta Stone for our entire conversation today. Just look at how perfectly the business model maps to the technology. The first line, the people executing trades, that's deal capture and endure. The second line, providing that critical oversight, that maps directly to the simulation and risk managers. And the third line, settling and accounting, well, that's the settlement module. And that's no accident. The system is literally designed to enforce this structure. So let's break down each line. Okay, let's start with the first line of defense, the front office. You can think of these folks as the value generation engine of the entire trading business. They're the ones on the front lines, interacting with the market and creating all the initial positions. Their world revolves entirely around execution. They're capturing new deals, they're constantly optimizing their book, and they're watching their P&L like a hawk in real time. But here's the most important part for us as system experts. Everything begins here. They're the initial point of data entry and the quality of every single downstream process. Risk, settlement, reporting, it all depends completely on the accuracy of what they capture right at the start. And right here, you can see their digital cockpit in Ender. They practically live in the trading manager for deal capture, they rely on the market manager for pricing, and they use the simulation manager for those quick intraday P&L checks. But notice their KPIs. It's all about precision, P&L accuracy, position reconciliation, hedge effectiveness. These are hard, unforgiving metrics. Let's make this super tangible. Imagine a trader over in Europe books a power forward deal. The very moment they hit save and endure, the system is already at work. It's validating the basic parameters of the deal and automatically slotting it into the correct portfolio. This is that first digital handshake in the trade's life cycle. Okay, let's move to that second line and see how this all connects. This is the middle office. And if the front office is the engine, the middle office is the governor on that engine. They are the independent control layer, making sure that engine operates safely and within its prescribed limits. Their entire job is oversight. They're the independent, sometimes skeptical voice on the trading floor. You could say their default position is prove it. They validate every single trade, they run those heavy-duty VAR simulations, they challenge and approve valuation models, and crucially, they're the ones who hit the brakes when a limit is breached. Their Endure toolkit is all about analysis and control. The simulation manager is their workhorse for VAR, credit manager is for tracking exposure, and the data quality framework, well, that's their secret weapon for data integrity. Now look at their KPIs. It's about accuracy, sure, but more importantly, it's about timeliness. See, risk information is perishable. A report that's late is a report that's useless. Their key metric is getting that T+0 risk run out the door on time, every single day without fail. And that brings us to our third and final line of defense, the back office. This is the ledger. This team is responsible for finalization. They make sure every single transaction becomes a settled, confirmed, and fully auditable fact in the company's books. So here's the crucial distinction. While the front office makes the deal and the middle office validates the risk, the back office makes it real. They confirm the trade details with the counterparty. They handle the actual flow of money through settlements and invoicing. They reconcile everything with the main company ERP, and they manage that mountain of regulatory reporting. They are truly the guardians of financial integrity. Their domain in Endure is the transactional heart of the system: settlement, accounting, and confirmations. Now look at these KPIs. While the front office is dealing with market volatility, the back office is dealing with zero tolerance for error, a settlement error rate of less than 0.1%, 100% audit compliance. In their world, close enough simply does not exist. It has to be perfect every single time.
So now that we understand the three teams, let's look at how OpenLink Endure itself acts as the digital backbone that enforces this entire structure. Because this isn't just about people sitting in different rooms. It's about system-enforced controls.
You see, this workflow isn't just a suggestion. It's hard-coded into Endura's DNA. A deal literally cannot move from capture to settlement without passing through the digital toll gates of risk validation and confirmation. The system itself enforces that separation of duties, making it impossible for a trader to confirm their own deal or for a risk analyst to process a payment. The technology becomes the guardian of the process. And we can take this a huge step further. We're moving beyond simple manual checks into the world of automated controls. By using Endure's powerful scripting tools like SQL and OpenJVS, we can build automated watchdogs that monitor the system 24/7. This is how you transform risk management from a reactive, after-the-fact process into something that is genuinely proactive. And here is a perfect example of that in action. Forget waiting for some end-of-day report. We can write a simple script that's constantly monitoring counterparty credit exposure. The second any counterparty crosses, say, a 90% utilization threshold, bam, an alert is automatically fired off to the credit desk. This isn't just data anymore. It's actionable intelligence delivered in real time.
And this is where it all comes together beautifully: the operational dashboard. This is mission control. Instead of a bunch of siloed reports, you have a single source of truth where each of the three lines can see the real-time health of the entire operation. This shared visibility is the absolute cornerstone of effective, coordinated control. All right, so we've seen the organizational theory and we've seen the technical tools. Let's try to distill all of this down to the key takeaways for mastering this ecosystem in practice.
Here are the crucial points to burn into your memory. First, this segregation of duties, it's not a nice to have. In the regulated world of energy trading, it is mandatory, period. Second, Endure is built from the ground up to support this model. Third, the winning combo is automation for proactivity and dashboards for visibility. That's what makes your operation resilient and perpetually audit-ready. And finally, for anyone aspiring to a senior role in ETRM, mastering this coordination is simply non-negotiable.
I want to leave you with this quote because it perfectly reframes the entire discussion. These control functions are not overhead. They are what enable the business to operate with confidence and with integrity. They build the trust with counterparties, with regulators, and with investors that allows the front office to do its job effectively.
So, we've laid out the blueprint for you. The question I'll leave you with is this: where in your own operation is there an opportunity to strengthen one of these lines? How can you use Endure's tools, not just for processing, but for proactive control? In our next chapter, we're going to build directly on this foundation as we dive deep into the specifics of managing credit limits, margining, and collateralization. Thanks for joining.
Hello and welcome. This is Durga Analytics, and we are diving right back into our expert level program on OpenLink Endure V25 Mastery. Today, we're getting into a topic that's at the absolute heart of risk management, Chapter 16, which is all about credit limits, margining, and collateralization. All right, for everyone who's been following the series, you know we're deep in Section 1, laying down the fundamentals of energy and commodities markets. Now, we've hit Chapter 16, and let me tell you, this is a topic that is absolutely critical to survival in this industry. For anyone who's serious about ETRM mastering this, well, it's just not optional.
So let's start with the big question, the one that keeps risk managers up at night. How in the world do you secure millions of dollars of exposure when the market can turn on a dime and change everything in milliseconds? Well, the answer isn't some magic button. It's a really sophisticated, automated process, and understanding exactly how that works, well, that's what separates the true experts from everyone else. Okay, before we can run, we have to walk. We're going to start by building a solid foundation. We need to get the core vocabulary down cold, because these concepts underpin every single action that happens inside Endor's credit risk modules. Let's get to it. So our first line of defense is the credit limit. You know, it's pretty much what it sounds like. It's a hard stop, a cap on the total financial exposure you are willing to have with any single counterparty. This is your number one control. And inside Endure, its home is the credit manager module. Now, having a credit limit is a great start, but it's really just a number in a system. The real rules of the game are laid out in the Credit Support Annex, or what we all call the CSA. Think of this document as the legal backbone of your entire trading relationship. It dictates exactly how, when, and what kind of collateral gets moved around. And if your CSA isn't configured perfectly in the system, well, your whole margining process is basically built on sand. And inside that CSA, you'll find two key terms that work together to keep things running smoothly. First, you've got the threshold. That's basically your pain point. It's the amount of unsecured risk you're willing to live with before you even pick up the phone to make a margin call. Then you have the MTA, or minimum transfer amount. This is really just a practical filter. It stops you from wasting everyone's time chasing a counterparty for, I don't know, 100 euros. It makes sure every margin call is for a meaningful amount and prevents total operational chaos. So your counterparty posts some collateral. Great. But is €1 million in cash the same as €1 million in a corporate bond? No way. Absolutely not. And that's where the haircut comes in. It's a risk-based discount that you apply to any non-cash collateral. And this example shows it perfectly. A €5 million bond with a 5% haircut, it only gives you $4.75 million in actual credit coverage. This protects you in case that collateral itself starts to lose value. All right, so that's the theory. We've got the key concepts down. Now for the fun part. Let's see how this whole framework is actually built in practice. We're moving from just ideas to actual configuration, looking at how all of this comes to life right inside OpenLink Endor. You have to remember that credit risk is never static. It's this dynamic, continuous control loop that's always running. And this slide maps it out just right. A trade gets booked and your exposure goes up. The system runs simulations to calculate the new mark-to-market exposure. Then the credit manager checks that against the limit. If a threshold is breached, boom, a margin call is triggered. Collateral gets posted, the exposure drops back down, and the whole cycle starts over again every single day. And here's what it actually looks like inside the system. Let's say we're setting up a limit record for Shell Trading UK. We define the value, of course, 10 million euros, but what's just as important, maybe even more so, is defining the automated actions. See here, we've set a warning threshold at 80%, and the breach action? Automatically escalate to the risk manager. This is how you do proactive risk management, not reactive. Okay, for our more technical folks in the audience, here's a quick peek under the hood. Behind that nice, clean user interface, this is the kind of SQL that's doing all the heavy lifting. Now, you don't need to be a programmer to get the point here. What this query is doing is constantly scanning all of your exposure data in real time. It's calculating that utilization percentage we just talked about, and it's instantly flagging any counterparty that dares to cross that 80% warning line we set up. So what does that query actually find? That's the crucial part. Take a look at this snapshot. Shell and Engie? They're looking fine, well within limits. But then you see BP Energy. They're at 95% utilization. That is deep in the red zone. Their net exposure is 9.5 million against a 10 million limit. And just like that, the system has automatically flagged a critical risk that needs someone's attention right now.
So the system has thrown up a red flag on BP. The alarm bell is ringing. What happens next? This is where the real magic happens. This is where the automation truly kicks in. As we dive into that core workflow that Endure initiates, the margin call itself.
Okay, so now we have a very real scenario based on that alert. We know BP's net exposure is 9.5 million euros. The system then automatically checks their CSA terms and sees they have a 1 million euro threshold and 2 million in collateral already with us. So the question the system has to answer right now is this: how much more cash do we need to make this position secure again?
So how does Endure figure out the call amount? It's actually pretty simple arithmetic. You take the total exposure, you subtract the unsecured threshold they're allowed, and then you subtract the collateral they've already posted. Endure crunches these numbers in an instant. And for BP, the answer is a margin call for a very significant 6.5 million euros.
And this incredible automation is all driven by code that looks something like this. What you're seeing here is just a little snippet of OpenJVS, which is Endure's own scripting language. But the logic is so powerful because it's so simple. If the exposure is greater than the allowed limit, which is their threshold plus any collateral they already have, then calculate the margin they owe and immediately fire off an alert. This is exactly how the system guarantees that a critical margin call is never, ever missed. So we've walked through the mechanics, from booking a trade to getting an alert to making the call. Now let's zoom out a bit and elevate this discussion to a more strategic level. How do all these system capabilities help you stay compliant with regulators and drive operational excellence? This, right here, is where real mastery is forged.
You know, one of the biggest headaches for any global trading house is this fragmented regulatory landscape. As you can see, the rules are just different depending on where you trade. In Europe, under EMIR, you're usually looking at daily margin calls. But in the US, under Dodd-Frank, you could get hit with an intraday call. That means you might have to post collateral in a matter of hours, not days. A system like Endure is absolutely essential because it has to be configured to handle both of these frameworks perfectly, or you're looking at massive regulatory fines. And all of this brings us right back to the quality of your collateral. This table just illustrates brilliantly how the system calculates the true risk-adjusted value of what you're holding. Cash is king, right? 0% haircut. But government bonds get a little 5% discount, and those riskier corporate bonds get a 10% discount. Endure applies all of this automatically to give you a crystal clear, accurate picture of how secure you really are.
So what does mastery actually look like in practice? What's the playbook? Well, this slide lays it out. First, automate everything you possibly can. Margin notices, confirmations, the works. Second, remember your system is garbage in, garbage out. You have to keep those CSA terms perfectly updated. And finally, and this is huge, this is not just a risk function. It requires daily, constant alignment between your risk, your treasury, and your legal teams. They absolutely have to operate as a single unit. And that brings us to our final and most critical question. Your system is configured, your reports are running smoothly. But I want you to ask yourself this. Is your collateral strategy truly resilient enough to survive the next black swan event? That is the strategic question that this entire process is ultimately designed to answer. Now that we've secured the risk, our next explainer, Chapter 17, is going to follow the money right through the settlement and invoicing process. Thanks for joining us.
Welcome everyone to another deep dive from us here at Durga Analytics. Today, we're getting into one of the most critical, high-stakes functions in any energy trading and risk management system: settlement and invoicing. This isn't just about sending out bills. This is the moment where all the value you've captured in trading becomes real, tangible cash flow. It's also where operational risk is at its absolute peak. So getting this right is it's non-negotiable.
All right, before we jump in, let's just quickly get our bearings. We are deep in Section 1 of our big Endure V25 program, which is all about the fundamentals of the energy and commodities market. We've already walked through the entire trade lifecycle, right from execution to risk management. So today, in Chapter 17, we're hitting that final, crucial step, settlement and invoicing. This is literally the process that turns all those trades into cold, hard cash.
So, here's how we're going to break it down today. We've got 4 key parts. First, we'll nail down what settlement really is. I like to call it the financial finish line. Then, we'll pull back the curtain on Ender's automated workflow, which is like a financial assembly line. From there, we'll dig into the mechanics of payments and accounting, basically how we turn data into dollars. And to wrap it all up, we'll talk about the essential controls, verification, audits, and best practices that ensure financial truth. So, let's get started.
Okay, Section 1. Look, to really get a handle on the mechanics and, more importantly, the risks involved, we need to be crystal clear on what settlement actually represents. It is so much more than just some administrative task at the end of a trade's life. It's really the culmination of the entire thing.
The best way to think about it is this. If trading is the race, then settlement is the financial finish line. This is that moment where all the strategy, all the risk management, all the deal making, it all gets converted into actual payments. And the goals here are really threefold. You need absolute accuracy in the amounts, you need it to be timely to manage your cash flow, and you need complete auditable traceability. You gotta have that for compliance.
Now, here's something you've really got to understand. Settlements are not one-size-fits-all. Endure is specifically designed to handle the whole spectrum, and it's all tailored to the nature of the trade. You've got your physical settlements. That's for the actual delivery of gas to a hub like TTF. You've got financial settlements for derivatives like swaps. You've got these complex hybrid deals. And of course, you've got collateral movements under a CSA, a credit support annex, to manage your credit risk. Each one of these has its own unique automated workflow right inside the system.
So the big question is, how does Endure actually manage all this complexity? Well, that brings us right to Section 2, where we'll look at the automated workflow. It's best to think of this not as a bunch of manual tasks, but as a super efficient automated financial assembly line. It's designed from the ground up to just crush errors and delays. And this slide, well, it lays out the whole end-to-end process perfectly. It all kicks off with a validated trade capture. From that point, Endure automatically generates all the financial obligations. We call that event generation. The system then automatically finds the right bank details using settlement instructions, pulls these events together for invoicing, and then creates the payment instruction. The loop finally closes with reconciliation, where your internal records get matched up against bank statements. It's a clean, systematic, and totally auditable journey from trade to cash.
Now, for all you technical and support folks out there, what's really powerful here is how Endure handles this at a data level. You can see it on the side. Every single cash flow becomes its own distinct record in the core ABTRAN event table. What does that mean? It means you have an unchangeable, easily queryable audit trail. An operations analyst or an auditor can run a simple query, just like this one, and instantly pull every single settlement event. It's complete transparency.
And this is where Ender gets really smart. It uses a powerful feature called netting to just dramatically improve efficiency and cut down on risk. I mean, just look at the comparison here. Instead of processing, say, 10 or 20 individual payments to a single counterparty, the system combines all your payables and receivables into one single netted cash flow. This is huge. It doesn't just cut down on bank fees and operational hassle, it also, and this is crucial, lowers your settlement risk and helps you optimize your daily cash position. All right, on to section 3. So the system has generated and netted all the financial events. Now we get to the core execution steps. This is where the rubber really meets the road. We're transforming those digital records into formal invoices, real payment instructions, and official accounting entries. We're turning data into dollars.
So what happens is the system gathers up all the relevant settlement events for a certain period and rolls them into a formal, legally binding invoice. This slide shows a perfect example for a European power forward deal. All the critical info is just automatically pulled from the trade and the counterparty setup. You've got the period, the due date, and the specific payment method required. In this case, a SEPA credit transfer, which is the standard for euro payments.
And that whole process crystallizes the total amount due. This number right here, 3.42 million euros. This represents the tangible, netted financial outcome of all your trading activity with that one counterparty for that one period. This is the final calculated result, and it's now ready for payment and for booking into the ledger.
And here's what's so important. Endure does not just stop at the invoice. At the exact same time, it's generating the corresponding double-entry accounting records, which you can see here are headed for the AB ledger table. It correctly debits accounts receivable and credits power revenue. This ensures the company's general ledger is always, and I mean always, perfectly synchronized with its real-time trading operations. That's a critical requirement for financial control. So finally, how do you actually pay? Well, Endure speaks the language of banks. It creates payment instruction files in all the standard formats. Whether you need a Swift MT103 for a global wire, a SEPA file for Europe, or even a custom format for your ERP system, Endure generates a file that's ready for straight-through processing. No more manual payment entry.
And that brings us to our final section, verification and best practices. Look, the life cycle isn't complete when you send the payment. It's only complete when you verify that it all settled correctly. This last phase is all about control, audit, and embedding best practices to ensure you have financial truth and you're always improving.
This is where the power of integration really shines. Endure automates reconciliation by systematically matching its own payment records against the bank statements that you import. A query, just like the example you see here, can be set up to run automatically. It joins the ETRM data with the bank data and instantly flags any discrepancies. For example, any payment that's off by more than, say, $10. Those get flagged for immediate investigation.
And listen, this automation isn't just some neat technical feature. It has a massive real-world impact on the bottom line. Just look at this case study from a U.S. LNG trading desk. Moving from manual to automated reconciliation cut down the time they spent on this from 4 hours a day to just 20 minutes. I mean, that's a reduction of over 90%. That is a huge gain, freeing up your experienced operations teams to focus on high-value exceptions instead of tedious manual box ticking.
So, to truly master this process and really leverage the full power of the system, organizations have to follow a clear set of best practices. This means automating everything you can, like nightly settlement jobs. It means enforcing dual controls for invoice approvals to stop unauthorized payments. It means having a real-time dashboard for exceptions, and of course, reconciling every single day. These aren't just suggestions, They are the essential pillars for a robust, auditable, and super efficient back-office operation.
At the end of the day, the goal and the real power of a modern ETRM system like Endure V25 is to achieve full straight-through processing, or STP. This is that seamless automated flow from the trade deal to the invoice to the bank payment and finally into the general ledger, all without anyone having to touch it manually. This creates a single, verifiable source of financial truth, which just drastically cuts down operational risk and makes sure your compliance posture is rock solid.
So, mastering the settlement lifecycle is absolutely key to realizing the value of your trading. And now that we really understand how a trade's financial life comes to an end, our next chapter is going to take us right back to the very beginning. we're going to explore the complex and varied contract structures, things like swing, take-or-pay, and power purchase agreements that kick this entire process off in the first place. I'm really looking forward to seeing you there.
Welcome, everyone. I'm your trainer from Durga Analytics, and today we're diving deep into our OpenLink Endura V25 Expert Program. We're going to move past the fundamentals and get into a topic that, honestly, separates the pros from the rest of the pack in the ETRM world: complex physical contract structures.
Now, as you know, this session is just one part of our massive 500-chapter curriculum. And our goal here isn't just to teach you the what, it's to get you to understand the why and the how. We want to elevate you from being just a system user to a real strategic leader. Whether you're a consultant designing these solutions, a risk analyst trying to quantify exposure, or an engineer building the integrations that make this whole thing tick. So, let's get our bearings. We're still in Section 1, really cementing our understanding of market fundamentals. We've talked about the life cycle of a trade, we've covered settlement, and now we're at a really pivotal point, Chapter 18. This is where we start to deconstruct the sophisticated contract structures that are, frankly, the real engines driving the physical energy markets.
Okay, I want you to put on your consultant hat for this session. Imagine your client has this incredibly complex portfolio of assets, and they're looking at you to translate all of that into a robust, auditable, and most importantly, profitable system setup. By the time we're done here, you are going to have the playbook to model, value, and manage the 4 core contract types that are the absolute backbone of physical energy trading.
So, let's just pause for a second and think strategically. The real money in energy trading, it isn't made on simple day-to-day spot trades. No way. It's made in the masterful management of flexibility, of optionality, and of long-term risk. I mean, we're talking about commitments that can span decades. So, how do the most sophisticated players in the market possibly codify and control all of that complexity?
Well, the answer is it's coded directly into the deal structure itself. You see, a world-class ETRM system like Endura is, at its heart, a translation engine. Its entire purpose is to take a dense 100-page legal agreement and transform it into structured, quantifiable, and manageable data that a trading desk can actually act on right now in real time.
So here's our game plan. We'll kick things off with contracts that manage volume. Then we'll move on to those that secure long-term supply and conversion capacity. And then, and this is the most important part, we'll see how to integrate them into a single, cohesive portfolio strategy. We'll wrap up with some key takeaways and best practices. Let's get started. First up, volume flexibility. You know, in physical markets, managing the quantity is every bit as critical as managing the price. And we're going to dissect the 2 workhorse contracts for this: swing and take-or-pay.
So, what is a swing contract? Fundamentally, it's a physical supply deal, but it's got a layer of financial optionality baked right into it. The buyer has the right, but not the obligation, to swing their offtake volume up or down within a pre-agreed band. This is the #1 tool a desk uses to manage those short-term, unpredictable swings in supply or demand.
Now, look closely at this slide. This is where a consultant really earns their money. Every single parameter you see here, the min-max take, the price index, that flexibility charge, it isn't just a random data point. In Endure, these are configured as specific constraints and pricing legs inside the physical gas forward deal template. That max take of 120%, that becomes a volumetric option, and the system's valuation models will actually price it using methods like Monte Carlo simulation. This is literally how legal language becomes executable logic.
And here's the result. This isn't theoretical. This is the tangible outcome of that logic. A European gas desk, by actively managing their swing nominations against that volatile day-ahead TTF index, so taking maximum volume on high-price days and minimum on low-price days, monetized the contract's optionality to the tune of 3.2 million euros. in a single winter. That's the power we're talking about.
All right, now for the flip side, the take or pay or top contract. If a swing contract gives flexibility to the buyer, a top contract gives security to the seller. It shifts the volume risk squarely onto the buyer's shoulders. They have to pay for a minimum quantity, whether they actually take the product or not. And it's this guaranteed revenue stream that underpins the financing for these multi-billion-dollar projects, like massive LNG liquefaction facilities. Now, for all the analysts and engineers with us today, here's a peek under the hood. You should never, ever blindly trust a system's calculations. A good risk analyst will always independently validate the key figures. This SQL query is a perfect example of that. It's a direct interrogation of the Endure database to make sure that the system's automated penalty calculation for a top contract matches the logic that's laid out in the legal agreement. It's all about trust but verify. And here's a case where that logic was put to the test. A U.S. LNG buyer just couldn't take their full minimum commitment, probably due to a warm winter and low demand. The take-or-pay clause in Endure functioned exactly as designed. It automatically generated a settlement invoice for a $60,000 penalty on that shortfall volume. This just goes to show you the very real financial teeth these agreements have.
All right, so we've got a handle on volume flexibility. Now let's zoom out a bit. Let's look at contracts designed to secure long-term supply and manage the physical conversion of assets. And this brings us to power purchase agreements, or PPAs, and tolling agreements.
Power purchase agreements are, without a doubt, the lifeblood of the energy transition. They are the #1 financial instrument used to fund new generation projects, especially renewables. By locking in a buyer and a price for 10, 15, even 25 years, a PPA provides the revenue certainty that banks need to finance the construction of a brand new solar or wind farm. This slide shows a classic corporate PPA. Now here's a common mistake I see people make in Ender. They try to model this as a simple fixed price power forward. That is wrong. You absolutely have to use the specialized PPA deal template. Why? Because that template lets you link the contract directly to a physical asset, that 100 megawatt solar farm, and its unique hourly generation profile. And that is essential for accurate valuation and settlement against what it actually produces.
And it is absolutely critical to understand the two flavors of PPA. A physical PPA, just like the name says, involves the physical delivery of electrons. But a virtual PPA, or a VVPA, is a purely financial derivative. It's basically a contract for differences that hedges price risk without any physical delivery at all. Endure can handle both, but they have completely different risk profiles, totally different settlement procedures, and different accounting treatments. Confusing the two is a major pitfall.
Okay, a tolling agreement is best understood with an analogy. Think of it like you're renting a factory. The toller provides the raw material, let's say natural gas, and they pay a toll fee to use the factory, the power plant, to convert it into a finished product, electricity. The key thing to remember is you are not buying power. You are buying the right to convert fuel into power at a very specific efficiency. That distinction is crucial.
So far, we've looked at all these contracts in isolation. But a master strategist never does that. The real value, and let's be honest, the real complexity, comes from integrating these different instruments into a single optimized portfolio. This is where we go from simple deal capture to true portfolio strategy.
This portfolio is a perfect illustration of that strategy. You've got a European utility using each contract for its specific strength. The renewable PPAs, that's their green, baseload energy. The tolling agreement, that's their dispatchable, on-demand power for when the wind isn't blowing or the sun isn't shining. And the swing gas contracts, that's the fine-tuning tool, used for daily and even intraday shaping to optimize the portfolio's final position. It's beautiful, really.
And here is the hard, quantifiable financial benefit of that integrated approach. By modeling and managing all these diverse contracts inside a single Endure portfolio,
The risk desk can actually see the natural offsets and hedges between them. And running a portfolio-level value-at-risk simulation like you see here revealed the 22% reduction in overall market risk compared to just looking at each contract in a silo. That is a massive improvement in capital efficiency.
So finally, how do you enforce all of these complex rules at scale? The answer is automation. This simple piece of OpenJBS code that's Endor's own scripting language acts like a digital guardrail. Think of it as an automated pre-deal check. If a trader or a scheduler tries to nominate gas outside the contractual swing limits, this script will fire an alert to the operations team in real time, preventing a costly breach of contract before it can even happen. So let's boil this whole chapter down to 6 core best practices. 1. Use the correct standardized Endura templates. 2. Integrate real-world production data for accurate settlement. 3. Model every single piece of flexibility and every penalty clause explicitly. 4. Always analyze risk at the portfolio level, not in silos. And 5. Automate your operational controls with tools like OpenJBS. Mastering these principles is what separates an average ETRM implementation from an elite one.
You know, ultimately what we've covered today is the critical bridge between commercial strategy and system execution. Being able to translate a legal contract into a robust system model is a core leadership skill in ETRM architecture. So as you continue on your expert journey, I want you to ask yourself, which part of this bridge, the commercial understanding, the system configuration, or the portfolio strategy, are you going to focus on strengthening first?
Thank you for your focus during this really deep dive. In Chapter 19, we're going to zoom out from the specifics of these contracts and look at the broader trading systems ecosystem. We'll explore how an ETRM system like Endor interacts with exchanges, scheduling systems, and enterprise ERPs to form a complete technology landscape. I really look forward to seeing you then.
Hey everyone, and welcome back to our deep dive with Durga Analytics. We're mastering OpenLink Endor v25. And today, we're tackling a topic that is absolutely essential for any serious architect or consultant, the trading systems ecosystem. All right, we are getting close to the end of Section 1, which has been all about market fundamentals. We've covered the what and why of trading, everything from physical versus financial deals to the full life cycle of a trade. So today, in Chapter 19, we're shifting from the what to the how. We're zooming out from Endor itself to really understand the entire universe of systems that it has to talk to every single day. Trust me, if you want to design and build these massive, complex solutions, this is where it all comes together. So here's our game plan. First, we'll map out the ecosystem blueprint. Then we'll follow a single trade on its journey through that system. We'll get into the nitty-gritty of the integration tools that make it all work, look at a couple of real-world company setups, and then wrap up with the best practices you need to keep this whole thing running smoothly. Okay, let's jump right in. First things first, we need to lay out the map. You know, before we can follow a trade, we have to understand the world it actually lives in. And that world is the trading ecosystem. You've got to understand that a modern trading floor isn't just one big piece of software. No way. It's this whole network of specialized systems. Right at the heart of it all, you've got your ETRM system. For us, that's OpenLink Endor. This is where the deals get done. But it doesn't work alone. It's constantly talking to the big company finance system, or ERP. It's pulling in live prices from market data providers. It's feeding data out to heavy-duty risk engines. And it's pushing results to BI tools for those flashy management dashboards. And the thing holding it all together? That's the integration layer, using tools like Kafka, which is kind of like the universal translator for this whole setup. So here's the key idea I want you to lock in. The best way to think about this whole ecosystem is like a central nervous system. Endor is the brain. It's processing every single transaction. It's taking in signals from the market, and it's sending commands out to the rest of the corporate body, to finance, to risk, to reporting. It's this constant, living, breathing flow of information. Okay, so we've got the map, Now let's actually trace a path through it. We're going to follow one single trade, from the moment it's created all the way until it shows up on a P&L report. This is where all that architectural theory gets real.
So, the journey kicks off the instant a trader hits save. The core data lands in Endur's main transaction table. The tech folks know it as ABTRAN. From there, a whole chain reaction starts. The system automatically creates all the necessary payment and settlement details in another table, ABTRAN again. Then, that triggers the creation of the actual accounting entries, your debits and your credits, in the AB ledger table. From there, it's off to the company's main finance system, like SAP, and finally, it gets visualized on those BI dashboards. And the best part? Every single step leaves a footprint, creating a perfectly clear, auditable trail.
And look, it's not just one single path we're talking about. It's more like a massive, multi-lane superhighway of data. You got trade data flowing to finance, complex risk numbers going to dashboards, live market prices streaming into Endor, settlement instructions zipping over to the Treasury Department, and crucial compliance reports being sent out to regulators. Endor is the traffic controller in the middle of it all, orchestrating everything.
Now, for all you developers and analysts watching, this is the good stuff. This is the proof. With a pretty straightforward SQL query like this one, we can literally connect the dots. We can trace a single trade with deal number 1, 2, 3, 4, 5, 6, all the way from its creation to the exact debit and credit entries in the general ledger. This ability to trace data is called data lineage. And in a highly regulated world like energy trading, it's not just nice to have, it's absolutely critical. Okay, so we know what data is moving and where it's going. But the big question is, how? How does it actually get there? Well, that brings us to our next section, the integration toolkit. Let's pop the hood and look at the tech that lets all these different systems speak the same language. Broadly speaking, there are two main ways these systems talk. You've got the traditional, file-based method, often called ABR. Think of this like the nightly mail delivery. It's great for big, scheduled jobs like processing thousands of settlements at the end of the day. Then you have the modern API-driven approach, using a tool called Open Components. This is like sending an instant message. It allows for real-time communication, which is perfect for things that need to happen right now, like booking a trade from a web portal. And check this out. This is literally what that instant message looks like. An external system packages up all the trade details into this neat little format called JSON, and then it sends it directly to Endor's Open Components service. Endor grabs it, validates it, and boom, the trade is booked instantly. This is how you get that real-time seamless integration. And remember, it's a two-way street. Data flows into Endor just as fast. This is where event-driven systems like Kafka are just game changers. A market data provider will publish a price update to a specific channel or topic. Endor is listening to that topic. The very second this message hits, it can kick off a full revaluation of the entire portfolio. This is how modern trading floors react to the market in seconds, not minutes or hours.
All right, enough theory about the individual tools. Let's see how this all gets put together in the real world. We're going to look at how two very different, very large energy firms, one in Europe, one in the US, have built their own high-performance trading ecosystems. First up, we've got a big integrated energy firm in the EU. They paired Endor V25 with SAP. For integration, they went with Kafka, specifically because it can handle that fire hose of market data without breaking a sweat. For analytics, they're using Snowflake and Power BI. And the key result here is just, wow. They've got it down to less than 15 minutes from the moment a trade is booked to it showing up in the official company books. That's incredibly fast. And this number, 99.9%, this really tells the story. That's their automated success rate for financial reconciliation. It means that almost every single transaction flows through the entire system without a human ever having to touch it. That doesn't just make them faster, it dramatically cuts down on errors and gives them massive confidence in their financial reporting. Now let's hop across the pond to a U.S. commodity trading desk. They're running Endor with an Oracle ERP. What's interesting here is they use a specialized tool, Numerix, for their advanced credit risk calculations, or CVA. This is a smart architectural choice. They're offloading the really heavy number crunching to a best-in-class engine. Their main goal, their North Star, was total automation. And they nailed it, 100% straight-through processing, 0 manual touchpoints.
And the business impact of that automation? Look at this, a 60% faster month-end close. That is a massive competitive advantage. It means the business gets its financial results way sooner so they can make faster, smarter decisions. It also frees up their finance team to do actual analysis instead of just chasing down data.
So, you see these amazing results, and you're probably thinking, how do I build that? Well, it takes more than just plugging in some software. It takes real discipline to build and maintain these systems. That brings us to our final section, the best practices for keeping this whole ecosystem healthy, reliable, and secure.
These are the golden rules, the absolute non-negotiables. You have to maintain that strict data lineage. It's about trusting your numbers. You must configure things like error retries and dead letter queues. That means one bad message won't bring down your whole system. And that last point about consistent identifiers, it sounds simple, but I promise you, getting a time zone or a currency code wrong between two systems can create unbelievably expensive nightmares to fix. These principles are what separate the fragile systems from the truly enterprise-grade ones.
And here's a super practical example of that in action. This little piece of code, written in Endur's own scripting language, is basically a watchdog for your system. It constantly scans for any integration jobs that have failed. If it finds one, it automatically fires off an alert to the operations team. This is proactive monitoring. You're finding the problems before they find you.
All of this really boils down to one key concept. And if you take one term away from today, let it be this one: system interoperability. It's just a fancy way of saying all your different systems can talk to each other and exchange data without any friction. How well you do this is what truly defines how mature and effective your trading organization is. If you're aiming for a lead architect role, this is your guiding principle.
All right, let's wrap this up. What are the big things to remember? First, the trading ecosystem isn't one system. It's many, and they're connected by real-time events. Second, Endure V25 is the central hub, the brain of the operation. Third, to get that real-time performance, you need to be using modern tools like Open Components and Kafka. And finally, none of it works without rock-solid governance to keep your data clean and compliant.
So, we've seen how Endure acts as this powerful brain in a really complex enterprise nervous system. And that naturally leads to a fascinating question, right? What is it about Endure's fundamental design, its core architecture? What is its secret sauce that has allowed it to be the market leader, playing this critical role for decades? We are going to explore exactly that in our next and final chapter of this section: why OpenLink Endure V25 remains the market leader. Thanks for joining me.
Hello, everyone, and welcome. I'm your trainer from Durga Analytics. Now, if you're in the energy trading and risk management space, you absolutely know the name Endure. But let's be honest, in a market that's getting more crowded, the big question is, why does its latest version, V25, still dominate? Well, in this deep dive, we're going to build the definitive case for its market leadership.
So, just as a quick reminder of where we are in our program, for the last 19 chapters, we've been building this deep foundation in energy market fundamentals, everything from physical trading to complex risk categories. Today, in our 20th and final chapter of Section 1, we're going to tie it all together by analyzing the platform that sits at the very center of this universe. Now, that is a bold claim, right? And our goal today is to really dig in and prove why this statement holds true. We're going to go way beyond just the simple feature list. We're going to look at the architectural philosophy and the proven real-world results that truly underpin Endure's dominance.
So here's our game plan. First, we'll lay out the core leadership claim. Then, we'll trace its evolution into the modern powerhouse it is today. After that, we'll stack it up against the competition, and finally, we'll look at the hard data, the proof in its performance, and the blueprint for success it offers. Okay, so let's start at the very top. What is the fundamental thesis for Endur's dominance? Why is it the benchmark that basically all other systems are measured against? So here it is, the core thesis. Endur isn't just another trading system. It's a complete, comprehensive enterprise platform. This idea of a single, unified data model that covers the entire commodity lifecycle, from the instant a trade is captured all the way through to final settlement, that's the central theme we're going to keep coming back to today. But look, this leadership position didn't just happen by accident. To really get why Endur is so dominant today, we have to look at its strategic evolution. It's been on this deliberate journey of modernization, from what was a classic monolith to a more flexible, microservices-based core. Now, what's really fascinating about this slide is the clear pivot point you can see right around versions 19 to 21. This is where ION's investment really started to pay off. And you see this shift from a robust but kind of monolithic system with its core in the JVS scripting language to a modern, API-driven, cloud-native platform. That right there is the inflection point. And open components, this is the key technical innovation that made that shift possible. The best way to think of it is that it transformed Endur into the central nervous system for an entire energy trading enterprise. It's not just some add-on, it fundamentally re-architected how this system talks to the outside world, enabling real-time data flow and, frankly, incredible extensibility. Okay, so we've got this modernized, API-driven architecture. But what does that actually mean when it comes to a competitive edge? It's one thing to have great tech under the hood. It's a whole other thing to win in a head-to-head comparison. So let's look at the data. And this chart, it just brilliantly illustrates the gap. Now, while some competitors might excel in a niche area, maybe they have a lighter SaaS model or focus on one commodity, none of them offer the sheer breadth and depth of Endur's unified platform. Just look at the full integration, the advanced credit, the built-in simulation. That is the enterprise-grade difference right there. This unified core is really the primary advantage. By having one system and one source of truth, you completely eliminate those costly, risky reconciliation breaks that just plague firms running separate systems for their front, middle, and back offices. It's what enables true straight-through processing, which, as you know, is the holy grail of operational efficiency. Now, this API-first approach means Endur doesn't just sit there and store data. It actively communicates and orchestrates workflows across your entire system's ecosystem. So a trade gets booked and bam, Kafka, the event streaming platform, instantly fires off events to update risk, credit, settlement, everything. It becomes a living, breathing part of your enterprise architecture. And finally, in today's environment, this one just cannot be overstated. With these incredibly complex rules, like Europe's EMIR or Dodd-Frank in the US, this built-in compliance framework is absolutely non-negotiable for any serious trading firm. It dramatically reduces regulatory risk and that massive manual overhead that's usually required to meet reporting obligations. All right, so theory and features are one thing, but the real proof is in the results. The ultimate test of any platform is the value it actually delivers in production. So let's examine how Endure V25 really performs out there in the wild. This first case study is a perfect demonstration of the power of consolidation. Constellation had nine separate systems. They replaced all that complexity and cost with a single, efficient core. And the results, they speak for themselves. A full return on investment in just 14 months. That's incredible.
And, it's not just about consolidating old systems. It's also about managing the insane complexity of modern, diverse energy portfolios. NG's success here shows Endur's ability to handle really intricate things, like power purchase agreements for renewables, right alongside traditional LNG logistics. All of it within a single, unified risk framework.
Okay, now let's zoom out from the individual stories and look at the aggregate ROI metrics from multiple V25 implementations across the industry. When you do this, the numbers are frankly absolutely staggering.
First up, an 84% improvement in the speed of value at risk calculations. For any middle office, this is a legitimate game changer. It means your risk managers aren't just running end-of-day reports, they can run more scenarios more often all day long. That leads to much tighter, more dynamic control over market exposure. Next, a 63% reduction in the time it takes to do the month-end close. Just think about the real-world impact of that. This isn't just a number. We're talking about giving your highly skilled finance and accounting teams weeks of their time back every single year so they can focus on strategic analysis instead of getting bogged down in manual reconciliation.
And finally, this one might be the most impressive of all, a near-perfect 97% rate of straight-through processing from trade to cash. This means trades just flow from execution to settlement with no manual intervention, which drastically reduces operational errors, minimizes settlement failures, and cuts costs across the board. This is what best-in-class performance really looks like. So the crucial point for you as a professional is, how do you actually leverage this powerful platform for maximum impact? What are the best practices for implementing and managing Endure V25 to get these kinds of results?
Well, mastering Endure V25 means you have to think bigger. You need to think like an enterprise architect. It's about way more than just configuring deals. It's about focusing on seamless integration, robust data governance, and peak performance to deliver strategic, measurable value back to the business.
So this is the final thought I really want to leave you with. Endura V25 has evolved way beyond being a simple ETRM. It truly is the central nervous system of modern energy trading. It processes signals, coordinates actions, and provides that single source of truth. Mastering it is a key differentiator for industry leaders.
So we've established why Ender leads the market from an architectural and performance perspective. The logical next step is to see this power in action. So in our next session, we're going to dive deep into the front office, exploring how traders and structures leverage this very platform to build complex physical and financial deals. I'll see you there.